welcome to our YouTube channel Knowledge Academy. The main aim of this lecture is to discuss about the signal and systems, which are the numericals which are present in the AS Gen Code Transcode Disco book. So whatever the questions of the signal and system which are present in the AS Gen Code Transcode Disco's book, that I am going to discuss in a very detailed manner. So if you like the content of our channel, then please like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever you upload more video, direct notes comes to our mobile. If any information read in our lectures, then please do comment in the comment section. We will definitely include all those information in the comment lectures. So why to waste more time? So let's get started. So this is the first question that we are going to discuss. See, the question says that let x of t is equal to v of t convolution of v of t, where the star marks denotes the convolution operation. So which of the following is false? So basically they are given x of t is equal to u of t convolution of v of t, where u of t and v of t are some unknown signals. So this star mark is nothing but it's a convolution. So out of these four options, we have to check is the false one we need to figure out. So option A, x of t is non-negative when both u of t and v of t are non-negative on the time axis. Option B, the area under the x of t equals the product of the area under the u of t and v of t. Option C, v of minus t convolution of v of minus t is equal to x of minus t. And the option D, which is v of t minus t naught convolution of v of t minus t naught is equal to x of t minus t naught. So out of these four options, option D is the false statement. So now let us discuss something more about this one. So here, see here, basically we can say, say I already told you x of t is equal to v of t convolution of v of t. Already they have given in the question, right? So x of t is equal to v of t convolution of v of t. So we know that convolution of two causal signals is always a causal signal. I have already told you. So basically, whenever you are doing a convolution of the two causal signals, the resultant is always a causal signal. So whenever you are doing the convolution of the two causal signals, again you are going to get the causal signal only. So whenever you are going to do the convolution of two causal signals, again you are going to get the causal signal only. So what is the meaning of causal signal? Causal signal means, suppose f of t is said to be a causal signal and f of t is equal to 0 for t less than 0, then that is called as a causal signal. Causal signal is also called as a right sided signal also you can call, because f of t is equal to 0 for t less than 0, it is called as a right sided signal or the causal signal. So combination of two causal signals, always you are going to get the causal signal only. So what is the meaning of this one? Suppose if v of t is equal to 0 for t less than or equal to 0 and v of t is equal to 0 for t less than or equal to 0. So what is the meaning of this one? V of t is a causal signal and v of t is also causal signal. Then x of t is equal to u of t convolution of v of t. Then what you are going to get? Then x of t is equal to 0 for t less than or equal to 0. Means if u of t is a causal signal, and if you are going to the convolution of these two signals, the resultant signal is also a causal signal. Means their value is equal to 0 for t less than 0. Means there is no negative values. So for negative time axis, there is no value. For negative time axis, there is no value. Then if these are non-negative, if there is no value in the negative time axis, then the resultant is also not having any values for the negative time axis. So we can say that x of t is a non-negative when both u of t and v of t are non-negative on the time axis. So we can say that if x of t is a non-negative, so we can say that x of t is non-negative when both u of t and v of t are non-negative on the time axis. So what is the meaning of this one? See, the time axis, negative time axis means there is no value. There is no value in the negative time axis. Non-negative means there is no negative values. There is no values on the negative time axis. If that is the case for both x of t and u of t, then simply the resultant is also a non-negative on the time axis. So therefore we can say that if u of t is a causal signal and v of t is a causal signal, in the combination of two causal signals, always you are going to get the causal signal. So this one always you have to keep in your mind. So therefore always you have to keep in your mind, whenever you are doing a combination of two causal signals, the resultant is also a causal signal. So whenever you are doing a combination of two causal signals, the resultant is also a causal signal. So therefore as u of t is a causal signal and v of t is a causal signal, the resultant x of t is also a causal signal. The next point is, suppose Ax is the area under the x of t graph and AU is the area under the u of t graph and AB is the area under the v of t graph. So Ax is called as the area under the U of t, x of t graph, and AU is the area under the U of t graph, and AB is the area under the U of t graph. Then in the question already I mentioned, if x of t is equal to U of t convolution of V of t, then Ax is equal to AU into AB. Means the area under the x of t graph is the multiplication of the area under the V of t graph and the area under the V of t graph. So always remember, which is this one I've already told you in my classes. So therefore we can say, if x of t is equal to U of t convolution of V of t, then the area under the x of t is equal to multiplication of the area under the U of t and the area under the V of t. So Ax is equal to AU into AB. So this one always you have to keep in your mind. So area under the x of t graph is nothing but is a multiplication of the area under the V of t graph and the area under the V of t graph. So if x of t is equal to U of t convolution of V of t, then the area under the x of t graph is equal to area under the U of t graph into area under the V of t graph. So this one always you have to keep in your mind. Suppose if U of t convolution of V of t is equal to x of t, then if you are going to have like this, U of at convolution of V of t is nothing but 1 by mod A into x of at. This one I have already told in the properties, right? This is I have already told in the properties. So U of at convolution of V of at is equal to 1 by mod A into x of at. A can be either positive or A can be either negative also. Suppose if A is equal to minus 1, then what we are going to get? Substitute here, if we are going to get substitute A is equal to minus 1, then this what we are going to get? V of minus t convolution of V of minus t is equal to 1 by mod of minus 1 is nothing but 1. So 1 into x of minus t. So V of minus t into V of minus t convolution of V of minus t is nothing but x of minus t. So this is the right statement. And I have already told you another formula, which is if U of t convolution of V of t is equal to x of t, then V of t minus a convolution of V of t minus b is equal to x of t minus of a plus b. So this is a general formula. This is a general formula. So U of t minus a convolution of V of t minus b is equal to x of t minus of a plus b. So this is a general formula as I already told you. Suppose if A is equal to T naught and B is equal to T naught, then what we are going to get? Suppose in the general expression I will substitute A is equal to T naught and B is equal to T naught. And if I substitute in this one, what I am going to get? V of T minus T naught convolution of V of T minus T naught is equal to x of T minus of T naught plus 2 T naught. So x of T minus 2 T naught. So these are the things that you always have to keep in your mind. So I want you to remember only very important things. The convolution of the two causal signals is always going to give a causal signal. So what's the meaning of causal signal? F of t is equal to 0 for t less than 0. Then that is called the causal signal. It is also called as the right-sided signal. And the area under the, we can say, whenever you are doing the convolution of two signals, the resultant signal area is the product of the individual signal areas. And I already told you, which is, suppose, I already told you, f of t convolution of h of t is equal to y of t. If you are going to assume, then f of at convolution of h of at is equal to 1 by mod A into y of at. This one I have already told you, A can be positive, A can be negative. And also, f of t minus a convolution of h of t minus b is equal to, we can say, y of t minus of a plus b. These things already I told you. So these things always you have to keep in your mind. So from this I can say that this is a true statement, option A is a true statement, option B is a true statement, and option C is also a true statement. But option D they are given wrong. But actually what it should be, actually, it should be like this, right? So U of t minus t naught convolution of the V of t minus t naught is nothing but it should be equal to x of t minus 2 t naught. It should be like this one. It should be like this one, right? So what are the true statements if I can say? X of t is non-negative when both V of t and V of t are non-negative on the time axis, and the area under the x of t equals to the product of the area under the U of t as well as the V of t, and U of minus t convolution of V of minus t is equal to x of minus t, and U of t minus naught convolution of V of t minus naught is equal to x of t minus 2 t naught. So these are the true statements, but they are given wrong. So this is the correct solution of this question. Now we are going to solve another question. See the question here. A system is said to be bistable if bounded input always yield bounded output by this criteria. So a system is said to be bistable if bounded input always yield bound output by this criterion. As I already told you, what is the meaning of bistability? For every bound input, if you are going to get a bound output, then only we can say that the system is said to be stable, otherwise it is said to be unstable. At least for even, see, suppose if you take some system, suppose the given system, For so many bounded input, you got the bound output. But for some bounded input, you got the unbounded output. So by default, we can say the system is said to be an unstable system. So even at least for one bounded input, if you are going to get the unbound output, then the given system is said to be unstable system. So for every bounded input, if you are going to get a bound output, then only we can say the system is said to be stable. Otherwise, even for any at least one bound input, if you are going to get an unbound output, then we can say the given system is said to be unstable. So they are given some statement they are given. So they are given some options and they are asking like this. Option A, an integer is stable but differentiator is not. Option B, a differentiator is stable but the integer is not. Option C, neither the differentiator nor the integrator is stable. And option D, both the differentiator and the integrator are stable. They are given this one repeatedly. So here we can say both the integrator as well as the differentiator, they are given stable. So out of these four options, which is the true statement we need to figure out. So basically here what they are given the meaning of the bipolar stability means for every bound input, if you are going to get a bound output, then only we can say the given system is said to be stable. So from this statement, we have to figure out what is the stability of the differentiator and the integrator we need to figure out. So out of the four options, option C, neither the differentiator nor the integrator is stable. Means we can also say it is differentiator as well as the integrator, both are unstable systems. This is a true statement. So now we'll discuss something more about this one. So listen carefully. See, bibound means for every bounded input, if the output is bounded, then only the system is said to be stable. So what I told you, for every bound, so what's the meaning of bounded? Bipolar stability means for every bounded input, if you are going to get a bounded output, then only we can say the given system is said to be a stable system. Even for at least one bounded input, if you are going to get an unbounded output, then we can say the given system is said to be an unstable system. So with this concept, now we will see whether the differentiator system is stable or not, that we are going to discuss. So this is a differentiator. Differentiator means, what is the meaning of differentiator? The output is the differentiation of the input. So this is a differentiator circuit. The input is the x of t and the output is the y of t. So output is a differentiation of the input. So y of t is equal to d by dt of x of t. Suppose I am going to assume the input as a bound input, which is x of t is equal to u of t. Is a bound input I am going to assume. Then I will see what is the nature of the output that I am going to see. If x of t is equal to u of t, then what is y of t? Y of t is equal to d by dt of x of t. X of t is equal to u of t. So d by dt of u of t is nothing but impulse signal. So y of t is equal to delta of t. So delta of t is nothing but impulse. So what is the meaning of input? Input is the unit step signal. So this is a unit step signal. This is the bounded. This is the bounded input. So this is the unit step signal. Input is a bounded input. But the output that we are going to get an impulse signal which has an area of unity, but its magnitude is equal to infinity. So therefore we can say this is unbounded because its magnitude is not finite. Its magnitude is not finite. It is unbounded. Whereas its area is equal to 1. So definitely this is not a bounded signal because impulse signal is not a bounded signal. So definitely we can say this is an unbounded signal. The given system is said to be an unstable system because even the input is there, bounded input, the output we are going to get an unbounded output. So therefore we can say that the differential circuit is a unstable system. So x of t is equal to u of t, it's a bounded signal, and y of t is equal to delta of t, it's an unbounded signal. So therefore we can say the given system is said to be an unstable system. So therefore the differential system is said to be an unstable system because even though we are going to give a bounded input, the output we have got the unbounded output. So by default we can say that the differential circuit is nothing but, or the differential system is an unstable system. Similarly, now let's go for the integrated system. So now we are going to analyze whether this integrated system is a stable system or unstable system that we are going to analyze. So this is the integrated system. So this is the integrated system. So input is the x of t and the output is the y of t and the output is the y of t. So output is the integration of the input. So y of t is equal to integration of y is equal to minus to t x of dt. So output is the integration of the input. So y of t is equal to integration of y is equal to minus infinity to t x of dt. So now I will suppose if I am going to give a bounded input like x of t is equal to u of t, then I will see what is the nature of the output that I am going to see. If x of t is equal to u of t, then what is the output? Y of t is equal to integration of y is equal to minus to t. X of t is u of t. x of tau is u of tau. So u of tau into t tau. So this is nothing but integration of the step signal is nothing but the integration of the step signal is nothing but ramp signal. So y of t is equal to r of t means t into u of t. So this is nothing but it is a ramp signal. So ramp signal is nothing but it is an unbounded output. So let me draw the graph here. The input x of t is like this is the graph. So this is the bounded input. So this is the x of t is the bounded input, which is nothing but u of t. But if you draw the output graph, then you are going to get like this. So output graph you are going to get like this. So this is the graph that you are going to get. So this is the graph you are going to get. So we can say this is the ramp signal. Ramp signal is nothing but unbounded. It is not having a finite value of the amplitude. As time goes on, the amplitude is 28 degrees. So this is the unbounded. So input is a bounded signal, but the output is unbounded signal. So by default, we can say the integrated system is also a unstable system. So as x of t is equal to u of t, it's a bounded signal, and y of t is equal to r of t, it's a ramp signal, which is an unbounded signal. So therefore, we can say that the integrated system is also a unstable system. So finally, what we can conclude? We can conclude that both the differentiated as well as the integrated systems, both the systems are unstable systems. So we can say both these differentiated system as well as the integrated system, both the systems are said to be unstable systems. So we can also say in the reverse process also, neither the differentiated nor the integrated is stable means this is another way of saying that both the differentiated system as well as the integrated system, both the systems are unstable system. So neither the differentiated nor the integrated system is stable, or both the differentiated as well as the integrated systems, both these systems are unstable systems. You can call it any way. Anyway, the concept is same. So this is the correct solution of this question. So now let's go for the another question. The question says that a low pass signal having a bandwidth of 3500 Hz is sampled such that a broadband is available for ease in filtering. The sampling frequency used is 7500 Hz and the God bandwidth is, listen carefully, a low pass signal having a bandwidth of 3500 Hz is sampled such that a God band is available for ease in filtering. The sampling frequency used is 7500 Hz and the God band is. So basically this question what they are given a low pass signal which is having a bandwidth of 3500 Hz. Now basically the signal is sampled with a sampling frequency of 7500 Hz, keeping in mind a certain amount of broadband for it is useful for available for easy filtering. Then we have to find what is the God bandwidth we need to figure out. So there are four options. Option A, 500 Hz is the correct solution of this question. So let's solve this numerical. So as you can see clearly what they are given, basically they are given a signal, right? They are given a signal. This signal bandwidth is nothing but FM. FM is the maximum frequency. Bandwidth is nothing but the maximum frequency, because I am going to assume the minimum frequency is 0. I am going to assume. Suppose let me take like this. So let me take a signal like this. So we can say there is a positive frequencies and there is a negative frequencies. Bandwidth means only we have to consider the positive frequencies. So what is the maximum frequency? Maximum frequency is nothing but maximum frequency minus 0. So this is the maximum frequency, right? So this is the maximum frequency and this is the 0. Maximum frequency is FM. FM minus 0 is equal to bandwidth. So what is FM? FM is equal to bandwidth of the signal. It is nothing but 2500 Hz. And also they are given the sampling frequency is equal to 7500 Hz. So with the sampling we are going to sample the signal. Sampling frequency is equal to 7500 Hz. So what is the God band we need to figure out? So God band is nothing but this much amount of gap that we need to keep between the two signals. So therefore there is no amount of aliasing. So between these two things, between the two signals, we have to keep this much amount of band gap. So let me draw the picture here. So I've already told this concept. After the convolution, we are going to get like this. After the convolution, what we are going to get? So this is a graph you are going to get after the convolution. So this is a Fs. So this is nothing but Fs minus Fm. So this is nothing but Fm. I already told you that. And this is nothing but God band. So this is nothing but God band. Bj I am going to write. So this much amount of gap that we need to keep within the process is if you don't want any reaction to happen. So therefore this follows the God band. So now you can see clearly how you can write this expression. How you can write this expression, just simply you can write like this, right? So this value is nothing but Fs minus Fm is nothing but it is equal to Fm plus Bg, right? So if simplify what we are going to get Fm is Fs is equal to 2Fm plus Bg, right? 2Fm plus Bg, same thing. So Fs is equal to 2Fm plus Bg, same thing we can write. Fs is equal to 2Fm plus Bg, same thing we can write. So Fs, so this is 500 hertz. 2 into Fm, 3500 hertz plus Bg. So if you simplify, 2 into 3500 is nothing but 7000. So here it is 7500. So Bg is equal to 7500 minus 7000 nothing but 5 hertz. So Bg value is equal to 5 hertz. So what is Fs? Fs is called sampling frequency and it's in this hertz. Fm is called as a bandwidth or the frequency of the message signal. It's in this hertz. And Bg is called as a God band. God band is nothing but it's also what is hertz because if this is hertz, if this is hertz, and this is also hertz. So this is the hertz. So this is the correct solution of this question. So I wanted to remember the basic formula. So let me tell you the basic formula. The general expression that you have to remember. Fs is suppose if you Fs is not equal to 2 times of Fm plus Bg. This is the formula that you have to remember for no aliasing. For no aliasing. Suppose if Bg is equal to 0. Suppose if Bg is equal to 0 means Fs is not equal to 2 times of Fm. If Bg is equal to 0. If Bg is equal to 0, this is what I want you to remember of this formula because Fs is equal to 2 times of Fm plus Bg. And Fs is sampling frequency and Fm is the message frequency and Bg is the God band. So this is the formula for no aliasing. And if Bg is not equal to 0. Suppose if Bg is equal to 0 means we are going to get a special case which is Fs equal to 2 times of Fm. And the minimum sampling frequency is called as the requested frequency. This also I already told you. So I want to remember the minimum sampling frequency for no aliasing is nothing but it is called as the requested rate or requested of requested frequency. We can call it any way. So this one always you have to keep in mind. The minimum sampling frequency is called as the requested frequency or the requested rate. So you have to remember Fs equal to 2 times of Fm plus Bg or no aliasing to occur. Here if Bg is not equal to 0 means like this you are going to get. If Bg is equal to 0 means you are going to get like this. So these things always you have to keep in mind here. So now let's go for the another question. The question is the output of a system is y of t is equal to x of 0 minus x of t. Where x of t is the input to the system is. So basically what they are given? They are given the output of a system is y of t is equal to x of 0 minus x of t. Where x of t is the input to the system is. So basically they are given some system. The input is x of t and the output is y of t is equal to x of 0 minus x of t. So now we have to comment what type of system is this. Option A linear and time varying. Option B non-linear and time varying. And option C linear and time invariant. And option D non-linear and time invariant. So the four options option D is a non-linear as well as the time invariant is the correct solution of this question. So whatever the system is nothing that it is a non-linear as well as the time invariant is the correct solution of this question. So let's solve this numerical. So let us solve this numerical. See clearly. So now basically we are going to first check the linearity property. So now for the system I am going to check the linearity property. That is my first case. So I am going to check the linearity property. So this is a system, right? So I already told you for the system what they are given. Suppose this is a system S. So for the system the input is x of t and the output is nothing but y of t. So what is y of t? Y of t they are given x of 0 minus x of t they have given, right? So now listen carefully. For the same system, if I am going to assume the input as x1 of t and what is the output? The output is nothing but which is y1 of t is equal to x of 0 minus x1 of t. Suppose for the same system, if I am going to give the input as x2 of t, then what is the output I am going to get? y2 of t is equal to x of 0 minus x2 of t. The x of 0 is nothing but it is a constant. Similarly, for the same system, if I am going to give the input as x3 of t, then what is the output? y3 of t is equal to x of 0 minus x3 of t. So now I am going to apply the superposition principle. So If the x of t is equal to x1 of t plus x2 of t means if this input is a summation of the two previous inputs. If the present input is a summation of two previous inputs, then the output should be equal to the summation of two previous outputs. Then only we can say the given system is said to be linear, otherwise it is a non-linear system. So let us see whether it is satisfying or not. If x of t is equal to x1 of t plus x2 of t, then what is y3 of t? Y3 of t is nothing but just we know x of 0 minus x3 of t, but we know x of t is nothing but x1 of t plus x2 of t as substitute here. So x of 0 minus of x1 of t plus x2 of t. So if you take minus inside, we are going to get y3 of t is equal to x of 0 minus x1 of t minus x2 of t. So this is the output that we have got for this input x3 of t. And I've already told you. So now we need to check whether this output is a summation of two previous outputs or not, that we are going to check, which is the summation of these two outputs, y1 of t plus y3 of t. If this summation, what we are going to get finally, 2 into x of 0 minus x1 of t minus x2 of t. If you do the addition of these two things, we are going to get like this. But if you see clearly, these two are not same. Here x of 0, here 2 into x of 0. So both are not same, they are different. So therefore we can say as y3 of t is not equal to y1 of t plus y2 of t, so we can say the given system is said to be nonlinear. Even though input is the new input is summation of two previous inputs, the new output is not a summation of two previous outputs. So therefore the superposition principle is not satisfied. So therefore we can say the given system is said to be a non-linear system. Even in shortcut method also you can check. In the shortcut method also you can check whether a given system is linear or not. Why? Very simple. Suppose if input is equal to 0, then output you should get as 0. So I have already told you for linear system. See, for a linear system, let me take it for linear system. Suppose if the input is x of t, then the output is y of t. Suppose if the input is a into x of t, then the output is also equal to a into y of t. Suppose if a is equal to 0, so what is the meaning of this one? If the input is equal to 0, for a linear system, the output is also equal to 0. So for a linear system, the input is equal to 0, then by default, the output should be equal to 0. Then only we can say the given system is said to be a linear system. This is the shortcut to remember. So you can see for the linear system, the input is x of t, then output is y of t. The input is a into x of t, then output is also equal to a into y of t. Means the input is multiplied by scalar quantity, and output is also multiplied by the same scalar quantity. If a is equal to 0, we can say input is equal to 0, so therefore the output is also equal to 0 for the linear system. So we can say that if the input is equal to 0, and if you are going to get the output is equal to 0, then we can say the given system is said to be linear, otherwise the non-linear system. If you see clearly, in this case, even though input is equal to 0, the output we are going to get is equal to x of 0. So definitely this is a non-zero value. So we can say the given system is said to be a non-linear system. Even though input is equal to 0, but still the output is not equal to 0. So therefore we can say the given system is said to be a non-linear system. This is a shortcut. In the examination, we have to go for the shortcut, but not this actual procedure. We have to go only for the shortcut. So if the input is equal to 0, and if you are going to get the output is equal to 0, then only we can say it is a linear system. And if the output is not equal to 0, then we can say the given system is said to be a non-linear system. In this case, we have checked that the given system is said to be a non-linear system. So now we are going to check the time varying property, whether the given system is a time varying system or time invariant system, that we are going to check. So this is a system, right? For the system, the input is x of t, and the output is diagonal y of t is equal to x of 0 minus x of t, already diagonal. Suppose for the same system, if I am going to assume the input is x1 of t, then what is the output? y1 of t is equal to x of 0 minus x1 of t. So what I will do, I will assume this input is the delay of the previous input. So if x1 of t is the delay of the previous input, means if x1 of t is equal to x of t minus t naught, then I will see what is the output that I am going to get. I am going to say if this new input is a delay of the previous input, then I will see what is the output that I am going to get. So y1 of t is equal to x of 0 minus x1 of t, but x1 of t is x of t minus t naught. So this is the output that we are going to get. And I have already told you, suppose if this system is a time invariant system, then what should get here? Here is x of t, means here x of t minus t naught, means here you should get y of t minus t naught. Suppose if the given system is a time invariant system, means the input is delayed by some amount of time, the output should be also delayed by same amount of time. So y of t, y of t is equal to x of 0 minus x of t, but I want y of t minus t naught. Wherever t is there, 3 plus t by t minus t naught, so therefore we are going to get y of t minus t naught is equal to x of 0 minus x of t minus t naught. And if you see these two equations, both are same, right? So both are same. Just y1 of t is nothing but y of t minus t naught. So if the input is delayed by some amount of time, the output is also delayed by the same amount of time. So therefore we can say the given system is said to be time invariant system. As y1 of t is equal to y of t minus t naught, then the given system is said to be a time invariant system. Means if the input is delayed by some amount of time, and if the output is also delayed by same amount of time, then only we can say the given system is said to be time invariant system. Otherwise, the time invariant system in this case, it is satisfies the time invariant property. So therefore, we can say the given system is said to be a time invariant system. So what I can say finally? Finally, I can say the given system is a nonlinear system as well as the time invariant system. So this is the correct solution of this question. So therefore, we can say the given system is said to be a nonlinear as well as a time invariant system. So this is the correct solution of this question. So now let's go for the other question. See the question here. Two signals x1 of t and x2 of t. The two signals x1 of t and x2 of t is equal to minus 2 into x1 of minus t are applied to the same linear time invariant system. Let the corresponding outputs produced to be y1 of t and y2 of t. Then what is the relation between it? We need to figure out. So suppose they have taken some LTI system, linear time invariant system. If the input is x1 of t means output is y1 of t. If the input is x2 of t, x2 of t means the output is y2 of t. If x2 of t is equal to minus 2 into x1 of minus t, then what is the relation between the outputs y1 of t and y2 of t? We need to figure out. So the four options, option D, y2 of t may not relate to y1 of t in any simple manner at all. So this is the correct solution of this question. So y2 of t may not relate to y1 of t in any simple manner at all is the correct solution of this question. So let's solve this numerical. As you can see clearly, this is the LTI system already they have given. So for this LTI system, if the input is x1 of t and the output is y1 of t, the same LTI system, if the input is, suppose the same LTI system, the input is minus 2 into x1 of t and the output is minus 2 into y1 of t, because I've already told you, if the input is multiplied by some scalar quantity, the output is also multiplied by the same amount of scalar quantity. The scalar quantity is minus 2. So minus 2 into x1 of t is nothing but output is also equal to minus 2 into y1 of t. Suppose minus 2 into x1 of t I am going to also this is x2 of t, then this will be nothing, this will be nothing but y2 of t. So this is x2 of t means this is the y2 of t. If x2 of t is equal to minus 2 into x1 of t, then y2 of t is equal to minus 2 into y1 of t. But if x2 of t is equal to minus 2 into x1 of minus t, this is something but reversal property. See, I want you to remember only one thing. If x2 of t is equal to minus 2 into x1 of t, then y2 of t is equal to minus 2 into y1 of t. This is a relation. If this is the input means this is the output relation. If suppose, if a time reversal property is there in the input, then we do not, in the linearity LTI, only two conditions are going to get satisfied. The linearity as well as the time invariant. Only these two things only the system is going to get satisfied, but not the time reversal. We don't know anything about the time reversal for the LTI systems. So we don't know what to be the output for a time reversal. So therefore, the LTI system means it is going to satisfy with the two properties, one is the linearity property and the time invariant property, but not the nothing about the reversal. Time reversal property is not yet satisfied. So as a time reversal operation, is a time varying operation, so y2 of t may not relate to y1 of t in a very simple manner. So y2 of t may not relate to y1 of t in any simple manner at all. So what I am trying to do is very simple. As a time reversal is there, as a time reversal operation is basically a time varying operation. So therefore y2 of t may not relate to y1 of t in a very simple manner. Please, even though they are going to relate, they are going to relate in a very complex manner, but not in a very simple manner. So therefore we can say that if y2 of t, see, as there is a time reversal property is there in the input, then we don't know what is the output that we don't know. So we don't know what is the output. So there is no way of relating the y2 of t and y1 of t in a very simple manner. So if input, see, if input x2 of t is equal to minus 2 into x1 of t, then only I can say y2 of t is equal to minus 2 into y1 of t. This I can say for LTI system. This is I can say for LTI system. But if the input x2 of t is equal to minus 2 into x1 of minus t, then I can't write in a very simple manner. I can't relate y1 of t and y2 of t in a simple manner. I cannot relate in a simple manner because of the time reversal property is there. Here there is no time reversal property, but here there is a time reversal property. So therefore, as a linear system is going to satisfy with the linearity as well as the time invariant property, but not the time reversal property. So therefore, we can say the time reversal operation is basically time invariant operation. So therefore, y2 of t may not relate to y1 of t in a very simple manner. So we don't know the exact relation between the y2 of t and y1 of t that we can't tell. So this is the correct solution of this question. So now we are going to solve the other question. See the question here. The output of a system is y of t is equal to 3 into x of t minus s square of t, where x of t is the input to the system is. So basically what they are given, the output of the system is y of t is equal to 3 into x of t minus s square of t, where x of t is the input to the system is. So basically they are given some system, right? They are given some system. The input is x of t and the output is y of t is equal to 3 into x of t minus s square of t. And what is the type of system that we need to figure out? Option A, linear and time varying. Option B, non-linear and time varying. Option C, linear and time invariant. And option D, non-linear and time invariant. So if you see all the options, we can say this system, they are asking about the linearity property and the time variant property. So out of these four options, option D, it's a non-linear system as well as the time invariant property is the correct solution of this question. See, we can solve this question in a very fraction of second. See, it is a sphere property. Sphere is nothing but it's a non-linear operation. So by default, we can say the system is said to be a non-linear system. Time invariant is there is a t, x of t and x of t. There is none other than there is nothing like t, 3t into x of t, t into x square of t. There are no coefficients with the variable time. So here if you see, here the coefficients are not variable with respect to time. If they are varying with respect to time, is a time varying system. Here these are the purely constant values. The coefficients are constant values, so therefore we can see this is a time invariant system. Just by seeing this, we can say as there is a square is a non-linear quantity. So by default, we can say the given system is a non-linear system. As the coefficients are constant, they are not variable. So therefore, we can say this is a time invariant system. By seeing only, we can say. But I will give you the actual procedure also. In case if you forgot, we can go for the actual procedure also. And this is a shortcut to remember. So finally, I can say the correct solution of this question is the given system is said to be a non-linear as well as a time invariant is the correct solution of this question. So let's solve this numerical. So now the first thing is I am going to check whether the given system is a linear or non-linear. I am going to check. So I am going to check the linearity property. So for a given system, if the input is x of t, then what is the output? Output y of t is equal to 3 into x of t minus s square of t. In the same system, the input is x1 of t, then what is the output? y1 of t is equal to 3 into x1 of t minus x1 of t whole square. In the same system, the input is x2 of t, then what is the output? y2 of t is equal to 3 into x2 of t minus x2 of t whole square. Similarly, for the same system, the input is x3 of t, then what is the output? y3 of t is equal to 3 into x3 of t minus s3 of t whole square. Right? So now, I am going to apply like this. If this new input is a summation of the two previous inputs, then I will see what is the output that I am going to get. If this new input is a summation of two previous inputs, then I will see what is the output that I am going to get. If x3 of t is equal to x1 of t plus x2 of t, then I will see what I am going to get the output. Output is nothing but y3 of t is equal to 3 into x2 of t minus x3 of t whole square. In place of x3 of t, I am going to substitute x1 of t plus x2 of t. So I am going to get it like this. y3 of t is equal to 3 into x1 of t plus x2 of t minus x1 of t plus x2 of t whole square. So now this is the output that you are going to get from this input. Now I am going to do the summation of the two previous outputs. Also I am going to do the summation. So y1 of t plus y2 of t, I am going to do the summation. Then I am going to get like this. 3 into x1 of t plus 3 into x2 of t minus of x1 of t whole square plus x2 of t whole square. So this is what I am going to get. And if you compare these two things, they are not same. They are different. Here there will be extra quantity of 2 into x1, x2, but there is no extra quantity. So definitely we can say these are not same. So if the new input is summation of the two previous inputs and a new input, if it is input summation of two previous outputs, then only we can say the given system is said to be linear system. Otherwise it is a non-linear system. In this case, even though input is the new input summation of two previous inputs, but the new output is not a summation of the two previous outputs, so definitely we can say the given system is said to be a non-linear system. So as y3 of t is not equal to y1 of t plus y2 of t, So therefore we can say the given system is a non-linear system. Or you can say square operator is a non-linear, so the given system is also non-linear. It's a shortcut to remember. As a square operator is nothing but it is a non-linear operator, so by default we can say the given system is said to be non-linear. In examinations, we have to go for the shortcut method but not the long method. But if it is any we can say main examinations, like subject examinations, you have to go in this procedure. Like all the things you have to go in a shortcut, right? So we can say the given system is said to be a non-linear system. So now we are going to check whether the given system is a time varying system or the time invariant system that I am going to check here, right? So this is a system. The input is x of t. What is the output? Y of t is equal to 3 into x of t minus x of t whole square, right? So for the same system, the input is x1 of t, then what is the output? Y1 of t is equal to 3 into x1 of t minus x1 of t whole square. Suppose if this new input is the delay of the previous input. If x1 of t is equal to x of t minus t naught, then I will see what is the output, then I am going to get, which is y1 of t is equal to 3 into x1 of t minus x1 of t whole square. In place of x1 of t, I am going to substitute x of t minus t naught. So I am going to get y1 of t is equal to 3 into x of t minus t naught minus x of t minus t naught whole square. And I already told you, suppose if the given system is a LT, we can say time invariant system. If the input is x of t means already we are going to get y of t. If the input is x of t minus t naught means then we have to get y of t minus t naught for a system to be time invariant. So if the input given to the same amount of time, the output should also be for a time invariant system. So now I will y of t expression we know. So I want to find what is y of t minus t naught. Wherever t is there, t plus t by t minus t naught. Then what are you going to get? Y of t is equal to 3 into x of t minus x of t whole square. So y of t minus t naught means wherever t is there, t plus t by t minus t naught. So therefore we are going to get 3 into x of t minus t naught minus x of t minus t naught whole square. And if we compare these two things, both are same, right? Both are same. So therefore we can say that as y1 of t is equal to y of t minus t naught, so therefore we can say the given system is said to be a time invariant system. Means if the input is given the same amount of time, the output is also given the same amount of time, so therefore we can say the given system is said to be a time invariant system. So finally, I can say that the given system is a non-linear system as well as a time invariant system. A shortcut to remember is whenever there is a non-linear operator like square and cube, by default we are saying that occasionally we can say the given system is said to be a non-linear system. And if the positions are constant, they are not variable, then we can say it's a time invariant system. But if the positions are variable with respect to time, we can say the system is said to be a time invariant system. So in this case, the given system is non-linear as well as a time invariant. So this is the correct solution of this question. So now we are going to solve the other question. So the question here, let delta of t denote the delta function. The value of the integration of minus m to plus m t delta of t into cos of dt by 2 into dt is the delta of t denote delta function of the impulse signal. You can call it anything into the delta function of the impulse signal. Then what is the value of the integral from t is equal to minus m to plus m t delta of t into cos of dt by 2 into dt we need to figure out. So there are four options. Option A, 1 is the correct solution of this question. So let's solve this numerical. As you can see clearly, integration of t is equal to minus m to plus m t delta of t into cos of dt by 2 into dt we need to figure out. The delta of t is called as the impulse signal, or it is also called as the delta function. So we have to find this integral. So we know from the shifting property. So what is the shifting property? We know integration of t is equal to minus m t to plus m to d f of t into delta of t minus t naught. dt is nothing but f of t naught. So this formula is called the shifting property. So integration of t is equal to minus m to plus m to d f of t and delta of t minus t naught dt is nothing but f of t naught. This formula, as I have already told you so many number of times. So by comparing this, what we can say, t naught is equal to 0. So t naught is equal to 0 and f of t is nothing but cos of 3t by 2. So f of t is equal to cos of 3t by 2 and t naught is equal to 0. Then what you are going to get? F of t naught means f of t naught is nothing but f of 0. So f of 0 is nothing but f of t is replace t by 0. So cos of 3 into 0 by 2 is nothing but cos 0 is equal to 1. So the value is equal to 1. So therefore, integration of t is equal to minus m to plus of d. Cos of 3t by 2 and delta of t dt is nothing but its value is equal to 1. So you have to remember the basic formula, which is integration of t is equal to minus m to plus of d. F of t into delta of t minus t naught dt is nothing but f of t1. So in this case, we can say f of t is cos theta by 2 and theta is equal to 0. We substitute values and if simplify, we are given the x value is equal to 1. And I want to remember only one thing, which is the simple signal should present in this integral. The simple signal should present in this time integral, then only this value you are going to get. Suppose if this is not lying in this integral, then its value is equal to 0. Listen carefully. The simple signal should lie in this integral of the time. Then only the value is called f of t1. Suppose if this is not lying in the time integral, then default, then we can say the value is equal to 0 because in this time integral, as delta of t is not present. So anything into 0 is nothing but 0 only you are going to get. So finally you are going to get 0. So I want to remember one thing. This integral, this delta, should lie in this time integral, then only the value is called f of t1. Suppose if the delta is not lying in this time integral, then therefore we can give the solution is equal to 0 in that case. So these things always you have to keep in your mind. So this is the correct solution of this question. Now we are going to discuss the another question. See the question here. Consider the compound system shown in the below figure. Its output is equal to the input with a delay of 2 minutes. The transfer function of the first system is given by h1 of z is equal to z minus 0.5 by z minus 0.8. Then h2 of z is. So what is the question they have here? Consider the compound system shown in the below figure. Its output is equal to the input with a delay of 2 units. The transfer function of the first system is given by h1 of z is equal to z minus 0.5 by z minus 0.8. Then what is h2 of z? We need to figure out. So in the question what they are saying is very simple. They are given some cascade system of the compound system is these two systems they are cascaded. So therefore we can say it is a component system. So for the first system the transfer function is h1 of z and for the second system the transfer function is h2 of z. So this overall system is going to perform like a delay system by 2 units. Means the output is the delay of the input by 2 units. The overall system is going to perform like a delay system by 2 units. Means the input is x1 of n, means the output is y of n. So y of n is equal to x of n minus 2. So this is the overall performance of this system. Say delaying the input by 2 units. So from this we have to find what is the h2 of z we need to figure out. So the 4 options of option B, h2 of z is equal to z to the power of minus 2 minus 0.8 into z to the power of minus 3 by 1 minus 0.5 into z to the power of minus 1. So this is the correct solution of this question. So let's solve this numerical. So this is the overall system we have given. It's a component system or the cascade system. So suppose if you want to write in the discrete time domain, how we are going to write? Discrete time domain is we are going to write like this in the discrete time domain. So this is the x of n, this is h1 of n, this is h2 of n, and this is y of n. But if you want to write in the z domain, then we are going to write x of z, h1 of z, h2 of z, and y of z. And you know, if you want to write in the convolution method, then what is the output? Y of n is equal to x of n convolution of the h1 of n convolution of h2 of n. So this I have already told you. Suppose if you want to write in terms of z transform, what are you going to get? Y of z is equal to x of z into h1 of z into h2 of z, because the conversion of the time domain will be used for the z domain. So therefore this will become h1 of z into h2 of z, and this is also to become into, because I already told you that conversion time domain will be used to the product in the z domain. So therefore y of z is equal to x of z into h1 of z into h2 of z. So what they have given? They have given h1 of z which is z minus 0.5 by z minus 0.8, and also they have given the system is going to perform like a delay system by 2 units. Means y of n is equal to x of n minus 2. Minus means delay, plus means advance. Delay means negative, advance means positive. As the output is the delaying the input by 2 units, means y of n is equal to x of n minus 2. So from this what we have to find what is h2 of z we need to figure out. So y of n is equal to x of n minus 2. So apply the z transform on both sides, then we are going to get y of z is equal to z to the power of minus 2 into x of z. So you know the basic formula, x of n plus or minus n naught, z transform is z to the power of plus or minus n naught into x of z. Here plus means here plus, here minus means here also minus. So this is a basic formula that you have to keep in mind in the z transform. In the z transform, this formula we have to keep in your mind. So therefore we can say that x of n plus or minus x of n plus or minus n of z transform into the power of plus or minus n of into x of z. Here plus, here also plus, here minus means here also minus. So here plus means here also plus, here minus means here also minus. So therefore we can say that x of n plus or minus n of z transform into the power of plus or minus n of into x of z. Here plus means here also plus, here minus means here also minus. So from this we have solved this question. So y of z is equal to z to the power of minus 2 into x of z here. So now what we are going to do is substitute here. So y of z is something but z to the power of minus 2 into x of z. Then h1 of z you know, and try to find the value of h2 of z. Very simple, right? So y of z is equal to x of z into h1 of z into x2 of z. So y of z you know, z to the power of minus 2 into x of z. This is same x of z and it is same as it is. This is h1 of z and this is h2 of z. So x of z everything cancels. We are going to get z to the power of minus 2 is equal to h1 of z into x2 of z. So same thing we are written here again. Z to the power of minus 2 is equal to h1 of z into x2 of z. So h1 of z value you know, z minus 0.5 to z minus 0.8. Now substitute here and then we simplify. Finally, you are going to get h2 of z is equal to z to the power of minus 2 into z minus 0.8 by z minus 0.5. So here what I will do, in the denominator I am going to take z as a common. So if I take z as a common, then what you are going to get z to the power of minus 2 into z minus 0.8 by, here I will take z as a common. So 1 minus 0.5 into z to the power of minus 1. If z goes to the upper part, it will become z to the power of minus 3. So same thing, z to the power of minus 3 into z minus 0.8 by 1 minus 0.5 into z to the power of minus 1. Z to the power of minus 3, take it inside, and what you are going to get? Z to the power of 1 into z to the power of minus 3, that will be z to the power of minus 2. Here, minus 0.8 z to the power of minus 3 by 1 minus 0.5 to the power of minus 1. So I have multiplied this z to the power of minus 3 inside for this term. So finally, you have got this expression. So this is the correct solution of this question. So in the question, what they have given very simple, right? They have given the outputs delay of the input by 2 minutes. So y of the is equal to x of n minus 2. I have going to z transform for the equation, then I have got y of z is equal to x of z into z to the power of minus 2. Then you know y of z is equal to x of z into h of z into h2 of z. I have substituted there, h of z, I have substituted there and got the value of h2 of z. It's a very simple question, right? So this is the correct solution of this question. So now we are going to solve another question. See the question here. The z transform of the signal. X of n is equal to 1 for n is equal to minus 1, x y is equal to 2 for n is equal to 0, and x y is equal to minus 1 for n is equal to 1, and x y is equal to 1 for n is equal to 2, and x y is equal to 0 otherwise. So basically they are given some discrete time signal. Discrete time signal they have given. And they are asking what is the z transform for the signal they are asking. So if you see clearly that this is a finite amplitude, finite time domain signal. Only it has a finite amplitude and also for a finite duration only the signal is present. Its value is equal to 1 for minus for n is equal to minus 1, its value is equal to 2 for n is equal to 0, and its value is equal to minus 1 for n is equal to 1, and its value is equal to 1 for n is equal to 2, and its value is equal to 0 otherwise. So for this discrete time signal, we have to find what is the z transform we need to figure out. So the 4 options, option A, z plus 2 minus z to the power of minus 1 z to the power of minus 2 is the correct solution of this question. So let's solve this numerical. So same thing, x of n I written, its value is equal to 1 for n is equal to minus 1, and its value is equal to 2 for n is equal to 0, and its value is equal to minus 1 for n is equal to 1, and its value is equal to 1 for n is equal to 2, and its value is equal to 0 otherwise, right? So same signal I written. So you know the z transform formula, x of z is equal to sigma n is equal to minus n to plus n to x of n into z to the power of minus n. So this formula you know, x of z is equal to sigma n is equal to minus n to plus n to x of n into z to the power of minus n. So this is the formula that you have to keep in your mind, right? So now we are going to apply this formula for this signal. Then what you are going to get? As the signal is having only finite amplitude and finite duration, so it is going to present only for these values of n. For n is equal to minus 1, for n is equal to 0, for n is equal to 1, and n is equal to 2. I am going to substitute these values. So x of z is equal to x to the power of minus 1 into the power of 1 plus x of 0 into the power of 0 plus x of 1 into the power of minus 1 plus x of 2 into the power of minus 2. And for remaining all other values, its value is equal to 0 because it is already they are given. So I have substituted here x of minus 1 into the power of 1 plus x of 0 to the power of 0 plus x of 1 to the power of minus 1 plus x of 2 to the power of minus 2. So you know all these values, right? I substitute all these values. Then what you are going to get? X of minus 1 is nothing but its value is equal to 1. And x of 0 is nothing but its value is equal to 2. And x of 1 is nothing but its value is equal to minus 1. And x of 2 is nothing but its value is equal to 1. I have substituted it and I have got like this, which is z plus 2 minus 1. This is minus 1 into z to the power of minus 1 is nothing but z to the power of minus 1. Minus into z to the power of minus 1. Z to the power of minus 2. So this is the x of z that I am going to get, just z plus 2 minus z to the power of minus 1 to the power of minus 2. See, and if you see, let me write this here, I am going to write here. I want to do some further analysis. So what you have got, x of z, you have got like this. What is the final solution that we have got? X of z. X of z is nothing but which is equal to z plus 2 minus z to the power of minus 1 to z to the power of minus 2. Suppose if they are asking the ROC, then what we can write here? Z plus 2 minus 1 by z plus 1 by z square. Suppose if you substitute z is equal to 0, then what you are going to get? 0 plus 2 minus 1 by 0 plus 1 by 0 square. This is something like infinity. 1 by 0 is something like infinity. Infinity plus some finite values always we are going to get infinity. Similarly, for x of z is equal to infinity, then what you are going to get? Infinity plus 2 minus 1 by infinity plus 1 by infinity square. 1 by infinity is about 0. 0 plus infinity is something like again infinity. Therefore, this z function is not defined for it is equal to 0 as well as it is equal to infinity. So what is the ROC? ROC means if substitute those values of ROC for those values of z, we are going to get the final value of x of z. Those is called as the ROC. So whenever you substitute some values of z and x of z, you should get a final value or not infinite value. If you are going to get infinite value means that is not even an ROC. So therefore, the ROC is nothing but what is the ROC? Now I can say except 0 as well as in C. I have to rub this equal set. I have to rub this value. So let me rub this point. There is nothing like equal. Except 0 as well as infinity. This is a ROC that I am going to get here. So let me rub this part. Again let me write here. So you can see this is the ROC. So this is the ROC that we are going to get for this signal. Now we can say what is the ROC? The ROC is nothing but except 0 as well as infinity, the remaining values of z, we are going to get the final value. So this is the ROC. So therefore we can say what's the meaning of ROC? If you substitute those values of z in x of z, you should get a final value that is called as a ROC. But if you substitute those values of z, if you are going to get infinity means that is not at all an ROC. The ROC is nothing but except 0 as well as infinity, the remaining thing is called as ROC. So what is ROC for the signal? The ROC is nothing but not it is going to lie between 0 and infinity, except the value of 0 as well as the except the value of infinity. The remaining thing is nothing but this is the ROC. Means all over the z plane except the 0 as well as the infinity. This is the ROC for this signal. So this is the correct solution of this question. Suppose if they ask the ROC, then we can write the ROC which is except the 0 as well as infinity. The remaining part is nothing but this is the ROC. So this we can write like this. So always you have to keep in your mind the z transfer form x of z is equal to sigma n is equal to minus n to plus n into x of y into t to the power of minus n. So this form always you have to keep in your mind. So this is the correct solution of this question. So now we are going to solve another question. See the question here. The transfer function p of s is equal to s by s plus a is that of a. The transfer function p of s is equal to s by s plus a is that of a. So basically they are given some transfer function of a filter. So what is the filter that we need to figure out? Option A, low pass filter. Option B, notch filter. Option C, high pass filter. And option D, band pass filter. So the four options, option C, high pass filter is the correct solution of this question. So this is a transfer function of a high pass filter. So this is the correct solution of this question. So let's solve this numerical. So what's the transfer function we have here? P of s is equal to s by s plus c. So we have to find what is the type of, what is the for. So for the which filter is the transfer function that we need to figure out. So in case of s, replace s by j omega, then we are going to get P of j omega is equal to j omega by j omega plus a. And I will try to find what is the magnitude value. The magnitude value of P of j omega is equal to omega by root over n square plus omega square. So for different values of omega, I want to see what is the magnitude of the transfer function I want to figure out. For omega is equal to 0, we are going to get 0 by A, we are going to get it is equal to 0. And if we substitute A, we are going to get A by under root 2 A square plus A square means A by under root 2 of 2A square means A by root 2 into A. A cancels, we are going to get 1 by root 2 we are going to get. If you substitute omega is equal to infinity, then what we are going to get? See, if you substitute omega is equal to infinity, then what we are going to get very simple. As omega is very, very high, so omega square plus A square is nothing but it is nearly equal to omega square only. Because as omega is very, very high, then A square is very less. So omega square plus A square is nearly equal to omega square. So omega by root 2 omega square is nothing but omega by omega is equal to 1. So we are going to its value is equal to 1. Also omega tends to infinity, is not a value, we are going to its value is equal to 1. So if I draw the graph, then what we are going to get? So the mod of P of j omega and with respect to omega, we are going to get like this. As the value of omega increases, the transfer function market value is also going to be decreases from 0 to 1. So you can see clearly when omega is equal to 0, its value is also equal to 0. If omega is equal to A, its value is equal to 1 by root 2. Its value is equal to 1 by root 2. And if its omega is equal to infinity, its value is equal to 1. So this is a graph that you are going to get. This is something like high pass filter. So this is called as the high pass filter. So this is the transfer function of the high pass filter. But you can solve in the fraction of second also. The other method also we can solve. What is a 0 here? 0 is equal to 0 and pole is equal to minus A. So if you plot in the S plane, then what you are going to get? So this is a 0 and this is a pole. So you can see clearly, this is something very lead compensator. 0 is closer to origin and compared to pole. So this is called as the lead compensator. Lead compensator, 0 is going to come earlier means we are going to plot. We are going to get the positive slope. Then we are going to get a slope of almost minus 20 plus 20 by 3 dB. So we are going to get a like this. This is nothing but high pass filter. We already told you that either you can solve this method or this method. The concept is same. So here what I did the angle method, the 0 is 0 and the pole is minus A. I have done the plot. This is 0 and this is a pole. So the 0 is closer to origin and compared to pole. This is a lead compensator. This is a lead compensator. So the lead compensator is also called as a high pass filter because 0 is going to come earlier. So we are going to get the positive results from weekend. And then we are going to get the pole. Pole is not minus 20. So positive the mass of the is nothing but 0 dB. So we are going to 0 dB. So this is nothing but high pass filter. Either you can solve in this method or in this method. Anyhow, the solution that you are going to get is same. This is the high pass filter. So this is the transfer function of the high pass filter is the correct solution of this question. Now we are going to solve another question. See the question here. A particular current is made up of two components. A 10 ampere DC and a sinusoidal current of peak value of 1.414 ampere. The average value of the resultant current is. Listen carefully. A particular current is made up of two components, a 10 ampere DC and a sinusoidal current of peak value of 1.414 ampere. The average value of the resultant current is. So basically in this question they are given some current is a combination of the DC current as well as the AC current. The DC current is 10 ampere and the AC current which is a sinusoidal current which is having a peak value of 1.414. So from this we have to find what is the average value of the result going to be interfere or this 10 ampere is the correct solution of this question. So let's solve this numerical. So as you can see clearly, I am going to write the expression which I of t is equal to 10 plus 1.414 sin omega t. The DC current is 10 ampere and this is the AC current or the sinusoidal current which is having a peak value of 1.414. So now we have to find what is the average value of the current. What is the average value of the current? With the DC value, that we are going to get is 10 ampere. And the DC value that we are going to get is 10 ampere. Suppose in the question if they ask the RMS value, then RMS value is nothing but root 2 10 whole square plus 1.414 by root 2 whole square. So root 2 is nothing but 1.414. Root 2 is equal to 1.414. So they are going to cancel. We are going to get root 2 10 square plus 1 square is equal to 100 plus 1 is 101. So 102 or 102 is nothing but 10.04 ampere. Suppose if they ask about the average current is 10 ampere and if they ask about the RMS value is 10.04 ampere. So this formula, as I've already told you, so let me write the formula. Suppose if f of t if f of t is equal to f1 of t plus f2 of t plus or minus, we will come to plus or minus. And what is f of the RMS value? RMS is equal to this when the is having a frequency of omega 1 and is omega 2. If omega 1 is not equal to omega 2, then only the formula is under root over f1 RMS whole square plus f2 RMS whole square. So this formula as a value only so one number of times. Here this signal frequency and this signal frequency are different. Then only you have to use this formula. In this case you can see this frequency is equal to 0 because it's a DC and the frequency is some omega. So both are different. Then only you have to use the formula which is under for signal RMS means for DC the RMS and RMS value are same, which is equal to peak value. It's the DC value which is 10 square plus for the side what is the RMS value which is peak value by root 2. So 1.414 by root 2. So if you simplify, we are going to get this result. So the average value is equal to 10 ampere, the RMS value is equal to 10.04 ampere. And you have to always keep in your mind, root 2 is nothing but 1.414 and 1 by root 2 is nothing but 0.707. These values always you have to keep in your mind. So this is the correct solution of this question. So what is the average value? It is equal to 10 ampere is the correct solution of this question. So that is the reason I have took the answer as 10 ampere. So this is the correct solution of this question. So now let's go for the other question. The other question is, what is the Laplace transform of the sine 2t whole cube? Or you can say sine cube of 2t into u of t. So the question they are asking, what is the Laplace transform of the sine cube of 2t? Sine cube of 2t that we need to figure out. Sine cube of 2t into u of t that we need to figure out. So the four options, option C is the correct solution of this question. So it's always related, which is 48 by s square plus 4 into s square plus 36. So basically, it should be like this one. Sine 2t whole cube into u of t into u of t. Or sometimes I write like this. Sine cube of 2t into u of t also they are going to write. But this is the actual thing that you can write for. If you don't want any confusion, is like this they are going to ask. For the signal, what is the Laplace transform that they are asking this question? So option C is the correct solution of this question, which is 48 by s square plus 4 into s square plus 36. So what is the correct solution of this question? So let's solve this numerical. So the Laplace transform of sine 2t whole cube into u of t, that is what we need to figure out. So before we solve this question, first let us know the formula. What is sine 3 theta? Sine theta is equal to 3 sin theta minus 4 sin cube theta. So this formula you have to keep in your mind. So let me write these two formulas that you have to keep in your mind. Definitely we will get one question for this concept. Sine 3 theta is equal to 2 sin theta into cos theta. Similarly, sine 3 theta is equal to 3 sin theta minus 4 sin cube theta. So these two formulas always you have to keep in your mind. Sine 2 theta is equal to 2 sin theta into cos theta. Sine 3 theta is equal to 3 sin theta minus 4 sin cube theta. So if you know this formula, very easy to solve this type of questions. So sine 3 theta is equal to 3 sin theta minus 4 sin cube theta. So I want to find what is the sin cube theta. If we simplify, we are going to get like this. Is 3 by 4 into sin theta minus 1 by 4 into sin theta. So I have got the expression of sin cube theta, which is nothing but this thing. So this is also like this type. So I am going to assume theta is nothing but 2t. So by comparing this, I can say theta is equal to 2t. So let theta is equal to 2t. Then what I am going to get? Sin cube of 2t is nothing but 3 by 4 into sin 2t minus 1 by 4 into sin of 3 into 2t is nothing but 60. So I am going to assume theta is 2t. If I simplify, we are going to get like this. Then multiply ut on both sides. Then what we are going to get? If multiply ut on the u of t on both sides, then we are going to get 3 by 4 into sin 2t into u of t minus 1 by 4 into sin 60 into u of t. It is equal to sin cube of 2t into u of t. And we know the basic formula. What is the basic formula? Sin 80 into u of t. What is the Laplace transform v by s square plus a square? This formula I have already told you so many number of times. Sin 80 into u of t is Laplace transform is a by s square plus a square. So here for this one I am going to apply the Laplace transform. So this Laplace transform is equal to this Laplace transform plus this Laplace transform. The minus is there, so you have to take minus of this Laplace transform. So Laplace transform of this integral is equal to 3 by 4 into, what is the Laplace transform of this one? Is nothing but, in A is equal to 2. So 2 by s square plus 2 square. So 2 by s square plus 2 square. Now this is one same as it is, 1 by 4 into sin 60 Laplace transform is A is equal to 6. So 6 by s square plus 6 square. So if we simplify, here 2 ones are 2 2s are. So 3 by 2 into s square plus 2 square minus 2 3s are 2 2s are. So we are going to get 3 by 2 into s square plus 6 square. So 3 by 2 is the same, and both these terms are going to take as a common. So 3 by 2 into 1 by s square plus 2 square minus 1 by s square plus 6 square. So now I am going to the LCM, this s square plus 2 square into s square plus 6 square. So 8 will be s square plus 6 square minus of s square plus 2 square. So minus goes inside this minus s square minus 2 square. So s square minus s square are going to cancel. 6 square is 36 minus 4. 36 minus 4 is equal to, it is equal to 36 minus 4. So what you are going to get? 32. So 3 by 2 into 32. 2 ones are 2, 6 are 16 3s are 48. So 48 by s square plus 4 into s square plus 36. The Laplace transform of sin cube 2t into u of t is equal to 48 by s square plus 4 into s square plus 36. So this is the first solution of this question. I want to remember only one form, which is sin 2 theta is equal to 2 sin theta into cos theta, and sin 3 theta is equal to 3 sin theta minus 4 sin 2 theta. So sin 2 theta is equal to 2 sin theta into cos theta, and sin 3 theta is equal to 3 sin theta minus 4 sin 2 theta. So if you remember these two formulas, then you can solve this type of question. So therefore we can say sin 2 theta is equal to 2 sin theta into cos theta, and sin 3 theta is equal to 3 sin theta minus 4 sin 2 theta. Then you know the basic formula of the sin 80 into u of the Laplace transform A by s square plus a square. So by applying that formula, we got the solution. So I give a summary formula also, you have to keep in mind. Sin 80 into u of t, the Laplace transform is a by s square plus a square, and cos 80 into u of t as the Laplace transform s by s square plus a square. So these are the basic formulas. I've told you this formula so many number of times, so you have to keep in your mind. Sin 80 into u of t, the Laplace transform is a by s square plus a square. Cos 80 into u of t, the Laplace transform is sin 80 into u of t as the Laplace transform a by s square plus a square. Cos 80 into u of t as the Laplace transform s by s square plus a square. What is the shortcut to remember? Here in the cos s is there, so in the middle s will be there. In the side there is no s here, so s is not there. So here cos means s is there, right? S is there means remember this s. Shortcut to remember. Here it will be yes. So sin 80 into u of t as the Laplace transform a by s square plus a square, and cos 80 into u of t as the Laplace transform s by s square plus a square. So these formulas you have to keep in your mind. So this is the correct solution of this question. We are going to solve the other question. See the question here. If the unit step response of a system is a unit impulse function, then the transfer function of the such system will be. If the unit step response of a system is a unit impulse function, then the transfer function of a such system will be. So what is the question they are asking? If the unit step response of a system is a unit impulse function, then the transfer function of a such system will be. Suppose they have taken some system. If the input is a unit step response, then the output that we are going to get is the unit impulse function. Then what is the transfer function for the system? We need to figure out. So if the unit step response of a system is a unit impulse function, then the transfer function for the system is, for a given system, the input is u of t and output is delta of t. U of t is a unit step input and delta of t is the unit impulse function. If that is the case, then what's the transfer function for a system? We need to figure out. So the four options, option C, this is the correct solution of this question. So let's solve this numerical. So you can see this is the system, right? So this is the system. The system is having a impulse response of h of t. So what this system, the input is x of t and output is y of t. The x of t is equal to u of t, and the output y of t is equal to delta of t already diagonal. If the input is a unit step input, the output we are going to get the unit impulse signal. X of t is equal to u of t, so y of t is equal to delta of t. So if you try to convert it to Laplace transform, then what you are going to get? This will become x of s, this will become h of s, and this will become y of s. So y of s is equal to x of s into h of s, already we know. So what is x of s? X of t is equal to u of t, so x of s is equal to 1 by s. So x of s is equal to 1 by s. And y of t is equal to delta of t, so y of s is nothing but the Laplace transform delta of t is equal to 1. So x of s is equal to 1 by s and y of s is equal to 1. And what is h of s? H of s is equal to y of s by x of s. Y of s value, 1. And as x of s value, 1 by s. So if you substitute and if you simplify, we are going to get the value is equal to s. So always you have to keep in mind some important formulas. For t to the power of n into u of t, what is the Laplace transform? The Laplace transform is n factorial by s to the power of n plus 1. Suppose if n is equal to 0, then what we are going to get u of t? Its Laplace transform is nothing but 0 factorial is 1. As the power of 0 plus 1 is equal to s. So we are going to get 1 by s, we are going to get for u of t. So for delta of t, the Laplace transform is 1. So this you have to keep in your mind. So for delta of t, the Laplace transform is equal to 1. So this formula always you have to keep in mind. The Laplace transform of e to the power of n into u of t is n factorial by s to the power of n plus 1. The Laplace transform delta of t is nothing but 1. So if you remember this one, h of s is equal to the Laplace transform of output by the Laplace transform of input, which is y of s by x of s. So y of s is equal to 1 and x of s is equal to 1 by s. And if we simplify, we are going to get its value is equal to s. The transfer function for the given system is equal to s is the correct solution of this question. So now we are going to solve the other question. See the question here. The Laplace transform of e to the power of minus at into f of t is. So in this question, they are asking what is the Laplace transform of the e to the power of minus at into f of t. They are asking this question. So the four options, option C, f of s plus a is the correct solution of this question. So let's solve this numerical. So we can see here. Say basically for f of t, the Laplace transform is f of s, then e to the power of plus or minus at into f of t is the Laplace transform f of s plus or minus a. Here plus means a plus, here minus means here also minus. Sorry, here reverse here. Sorry, it is reverse here. It should be minus and plus. So minus and plus, small correction. Minus and plus. So let me write again here. So just wait a second. Just give me 2 seconds so that I can make things very simple. So let me drop this part and let me write it again so that we can easily able to understand the concepts. So let's. This is f of s minus plus a. So you can see e to the power of minus a into f of t is f of s plus a. E to the power of s a t into f of t is f of s minus a. Here plus plus here minus here minus plus here plus. As you can see here, e to the power of minus a t into f of t is the Laplace transform f of s plus a. So e to the power of, so let me write here. So e to the power of minus a t into f of t as the Laplace transform f of s plus a. Similarly, e to the power of a t into f of t as the Laplace transform f of s minus a. So by this what we can say, here minus means here plus, here plus means here minus. Same thing I have written here. E to the power of plus or minus a t f of t Laplace transform is f of s minus plus a. Here plus means here minus means here plus. Similarly, f of t plus or minus a as a Laplace transform e to the power of plus or minus a is f of s. Here plus means here plus, here minus means here also minus. So let me write here. I have already told you, this you have to remember always. E to the power of minus a t into f of t as the Laplace transform f of s plus a, and f of t minus a as the Laplace transform e to the power of minus a s into f of s. If you know the basic formula, you can write for plus or minus also you can write. F of t minus a as the Laplace transform e to the power of minus a s into f of s. Then the derivative of f of t as the Laplace transform is the power of n into f of s. Similarly, to the power of n into f of t as the Laplace transform minus 1 over the power of n into the derivative of f of s with respect to s here. And the derivative of f of s with respect to s here. Minus 1 over the power of n into the derivative of f of s with respect to s. And f of a t has the Laplace transform 1 by mod a into f of s by a. Where a can be the positive, a can be the negative. So this formula is always you have to keep in mind. So finally, I can say the important formulas. What are the important formulas I can say? Which is e to the power of minus a t into f of t as a Laplace transform f of s plus a, and f of t minus as a Laplace transform e to the power of minus a s into f of s, and nth derivative. So nth derivative with respect to t of f of t as a Laplace transform as the power of n into f of s. This is for the bilateral transform, but not for the unilateral. Unilateral means there will be and the terms also will be present. This formula as a boundary tool. So what is the power of n into f of t as a Laplace transform minus 1 over the power of n into nth derivative of f of s with respect to ACL. And f of at as the Laplace transform, which is 1 by mod a into f of s by a, where a can be either positive or a can be either negative. So this form is also I only will. So always remember, if f of t is a Laplace transform f of s, then e to the power of minus 8 into f of t as a Laplace transform f of s plus n, and f of t minus a as a Laplace transform e to the power of minus a s into f of s, and the derivative of f of t as a Laplace transform is the power of n into f of s, and e to the power of n into f of t as a Laplace transform minus 1 over the power of n into the derivative of f of s with respect to s. And f of at as a Laplace transform 1 by mod a into f of s by a, where a can be either positive or a can be either negative. Okay, suppose for unilateral transforms there will initial conditions be there will be some extra terms here, otherwise, and this is a thing we are going to witness. For a bilateral transform there will be no extra terms. For the unilateral transform there will be extra terms are going to be present. So this one is already told you so many number of terms. So finally I can say for e to the power of minus 8 into f of t, the Laplace transform is f of s plus a. So this is the first solution of this question. So now we are going to solve the other question. See the question here. A system is causal if the output at any time depends only on. A system is said to be causal if the output at any time depends only on. And what do I tell you? A system is said to be causal only when the present output is depending on the present values of the input or the past values of the input, but not on the future values of the input. Then that system is said to be the causal system. Or simply we can say, if the present value of the output is independent of the future values of the input, then we can say the given system is said to be the causal system. So, a system is causal if the output at any time depends only on the option A, values of input in the past and the future. This is wrong. It should be independent of the future. So, option A is wrong. Go for the option C, the values of the input at the time and in the future. Future is definitely wrong. Option A means it is also wrong. Option B, values of the input at the time and also in the past. Yes. This is the correct way. So therefore we can say option B is the correct. So therefore we can say a system is said to be causal when the present value of the output is independent of the future values of the input. Means it can depend on the present values of the input or the past values of the input, but not on the future values of the input. Then only we can say the given system is said to be a causal system. So therefore finally I can say a given system is said to be causal when the present values of the output is depending on the present values of the input or the past values of the input, but not on the future values of the input. Then that is called as the causal system. So finally I can say a system is said to be causal if the present values of the present value of the output is independent of the future values of the input or depends on the present value of the input or the past values of the input, but not on the future values of the input. Then the given system is said to be causal. So option B is the correct solution of this question because the present values of the output is depending on the present value of the input and also in the past values of the input. So this is the correct solution of this question. So now we'll discuss something more about this one. A system is said to be causal if the present output is independent of the future values of the input. So I already told you, a system is said to be causal when the present value of the output is independent of the future values of the input. Or we can say a system is said to be causal if the present output is depending on the present input and the past input as well as the past output, but independent of the future values of the input. We can say it anything. So finally, I can say only one thing. A system is said to be a causal system if the present value of the output is independent of the future values of the input, or a system is said to be causal if the present values of the output depends on the past values of the input or the present values of the input as well as past values of the output, but not on the future values of the input. That is called as the causal system. So finally, I can say like this. A system is said to be causal if the present value of the output is independent of the future values of the input, or we can also say that a system is said to be causal if the present value of the output is dependent on the present values of the input, past values of the input, or we can say that past values of the output but not on the future values of the input. Then the system is said to be a causal system. So finally, a system is said to be causal if the present values of the output is independent of the future values of the input, or a system is said to be causal if the present values of the output is depends on the present value of the input as well as the past values of the input as well as the past values of the output, but it is independent of the future values of the input. Then that is called as the causal system. So finally I can say a system is said to be causal when the present values of the output is independent of the future values of the input, or a system is said to be causal when the present values of the output is dependent on the past values of the input as well as past values of and the present values of the input and the past values of the output, but not on the future values of the input. That is called as a causal system. So in simple words I can say, if the present values of the output is independent, the present value of the output is independent of the future values of the output. If the present values of the output is independent of the future values of the input, then by default we can say the given system is said to be a causal system. So a system is said to be causal if the present values of the input is. So finally I can say a system is said to be causal if the present value of the output is independent of the future values of the input, and then we can say the given system is said to be a causal system. So this is the correct solution of this question. Now we are going to solve the other question. See the question here. The region of the jet plane for which mod of z minus a by mod of z plus a is equal to 1, where the real part of a is not equal to 0. So definitely we can say a is a complex number. See, the real part of a is not equal to 0. So what is the meaning of this one? The a can be either purely real or it can be imaginary. Suppose if it is imaginary, the real part is not equal to 0. So basically, the region of the jet plane for which mod of z minus a by mod of z plus a is equal to 1, that we need to figure out. So at what region on the jet plane it is going to satisfy this condition, that we need to figure out. So the four options, option B, y-axis is the correct solution of this question. So let's solve this numerical. So we can say mod of z minus a by mod of z plus a is equal to 1. Where z is the thing of jet plane. So if you do the cross multiplication, what we are going to get? Mod of z minus a is equal to mod of z plus a. Here is what z is equal to s plus I by x plus I by. So here I have written mod of s plus I by minus a is equal to mod of s plus I by plus a. So I am going to keep the real part one side and the imaginary part on side. See, I am going to assume a is just a real number. A is a real number and its value is not equal to 0. Already they are given. A, its value is not equal to given. They are given. This A is the real number. Actually, they should say this is the real value. A is nothing but real value and its value is not equal to 0. A is nothing but a real value. A is nothing but A is a real value. They should write like this actually, but they have done in that manner. People may get confused. They may also get confused. So A is some real value and its value is not equal to 0. Already they have given here. So A is nothing but it's a real value and its value is not equal to 0. So I have substituted here. So I have taken the real part one side and the imaginary part one side. Then what I am going to get? Mod of x minus a plus I by is equal to mod of s plus a plus I by. So if you are going to if you try to find the mark, which is under root over x minus a whole square plus y square is equal to under root over s plus a whole square plus y square. So this is the mark of the complex number. So the square roots are going to get cancelled, and finally if you expand, what we are going to get? X minus a whole square plus y square is equal to s plus a whole square plus y square. So y square cancels. Finally we are going to get x minus a whole square is equal to s plus a whole square. X minus a whole square is nothing but s square plus a square minus 2ax is equal to s plus a whole square is s2 plus a square plus 2x. S2 square cancels, s square cancels. And if we take this 2x to the right side, we are going to get 4x is equal to 0. So x is equal to 0, then we are going to get x is equal to 0 means it is a y-axis, right? Y-axis means x is equal to 0 means it is the equation of the y-axis. So x is equal to 0. X is equal to 0 is the equation of y-axis. And y is equal to 0 is the equation of the x-axis. So this is about the x-axis and this is about the y-axis. See, in the x-axis, y value is always equal to 0. In the y-axis, x value is equal to 0 always. Listen carefully. On the y-axis, x value is always equal to 0. Or in the x-axis, the y value is always equal to 0. Or you can say like that. So x is equal to 0 is the equation of the y-axis. So what we can say? This is nothing but y-axis. The correct solution of this question means all the points which are going to present in the y-axis, they are going to satisfy this condition. So all the points which are going to lie on the axis, they are going to satisfy this condition. So this is the correct solution of this question, which is y-axis. So now we are going to solve another question. See the question here. The Laplace transform of the t square plus 2t plus 3 into u of t is. So basically, we have to find what is the Laplace transform of the t square plus 2t plus 3 into u of t. We need to figure out. So what are the four options? Option C is the correct solution of this question, which is 2 by s2 plus 2 by s squared plus 3 by s is the correct solution of this question. So let's solve this numerical. So you can see, we have to find what is the Laplace transform of the t square plus 2t plus 3 into u of t. For this, we have to find the Laplace transform. So before we solve this question, first you have to know the basic formula, which is, we know that e to the power of n into u of t, the Laplace transform is n factorial by s to the power of n plus 1. So if you know this basic formula, solving this is a very fraction of second. So I am going to take this u of t inside, then finally what I am going to get, f of t I am going to assume it is t square into u of t plus 2t into u of t plus 3 into u of t. So what is f of s? So if you need to apply the Laplace transform on each and every term, and everything is addition. So you have to do the Laplace transform for each and every term. So t square into u of t is equal to n is equal to 2. So 2 factorial by s to the power of 2 plus 1, which is 2 factorial by s2 plus 2 into t to the power of 1 into u of t. So n is equal to 1. So 1 factorial by s to the power of 1 plus 1 is 1 factorial by s square plus 3 into u of t. So you know, here n is equal to 0. So n is equal to 0 means we are going to 0 factorial by s to the power of 0 plus 1 is 1 by s we are going to get. So 3 into 1 by s. So if you simplify, what we are going to get, 2 factorial is 2 into 1, which is 2. So 2 by s2 plus 1 factorial is 1. So 2 into 1 is 1, 2. So 2 by s square plus this is 3 by s. So this is the that we are going to get. So this is the correct solution of this question. So therefore we can say that always keep it in mind, which is the Laplace transform of t to the power of n into u of t is n factorial by s to the power of n plus 1. So we can substitute the any value of n. So any value of n, if you substitute, you are because I think n is a positive integers. N is the positive integers, because for negative values there will be no factorial. So n is a positive integers. Positive integers means 0, plus 1, plus 2 like that. So positive is 0, plus 1, plus 2 and goes on. So these things always you have to keep in your mind. Okay, so this is the correct solution of this question. So now let's solve the another question. See the question here. The system response can be tested better with. The system response can be tested better with. The system response can be tested better with. Option A, sinusoidal input signal. Option B, unit impulse input signal. Option C, ramp input signal. And option D, exponentially decaying input signal. So out of this, so the system response can be tested better. In what way? We know the nature of the system response. By what thing we can get the nature of the system response. I already told you an important point. Suppose this is a LTI system. This is a LTI system. Suppose if we are going to this is a unit impulse signal, then we are going to get the unit impulse response. So if you know h of t, for any input you can get the y of t. Suppose if the input is x of t, then what is y of t? So y of t is equal to x of t convolution of the h of t, as I already told you. So if you know the h of t, no matter whatever the input, just by doing a convolution, we can get the value of the y of t. So if you know the unit impulse response, then I can say that no matter whatever the input, you can easily get the output just by doing a convolution of the input with the unit impulse response. So if you know the unit impulse response, then we can know the output in and out. Yes, we know each and everything regarding the output. The system response can be tested better with the unit impulse input signal. Means whenever you are going to give the input as a unit impulse signal, the output you are going to get the unit impulse response. So if you know the unit impulse response, then we can get the value of the output for any value of the input just by doing a combination of the input with the impulse response. So if you know the h of t, if you do the analysis of the h of t, then you can tell each and everything regarding the output y of t. These things I've already told you. Let us do something extra analysis regarding this one. The system response can be tested better with the unit impulse input signal. Means the system response can be tested better with the unit impulse input signal. So you can say this is the LTI system. For LTI system, if you are going to the delta of t as the input, then we are going to get the impulse response h of t. Suppose if you are going to give x of t as the input and h of t is the unit impulse response, then what is the y of t? Y of t is equal to x of t convolution of h of t. If x of t is equal to delta of t, then what is the value of y of t, which is nothing but unit impulse response h of t. This one I already told you. So delta of t is called as the unit impulse signal and h of t is called as the unit impulse response. Suppose if the input is x of t is equal to u of t, then what is y of t? Y of t is nothing but unit step response, which is s of t. So u of t is called as the unit step signal and s of t is called as the unit step response. So basically, I want to give the relation between these two inputs. So listen carefully. See, this is a system. For this system, if delta of t is the input, then what is the output h of t? Suppose for the same system, if u of t is the input, then what is the output, which is s of t? So I want to give the relation between one and another. If you know one thing, how to get the other thing that I am going to discuss. So you know the unit, the unit step signal is the integration of the impulse signal. So u of t is equal to integration of tau is equal to minus infinity t delta of tau deta. Means we can say the unit step signal is the integration of the impulse signal. So now if you know this thing, how to get the output relation? So u of t response is s of t, right? Integration of tau is equal to minus infinity t and delta of t response is the h of t, we say h of tau deta. So if you know h of t, then we can get the s of t just by doing the integration of the h of t. So step response is the integration of the impulse response. So step response is the integration of the impulse response. Similarly, vice versa, delta of t is nothing but d by dt of the u of t. This impulse signal is the derivative of the step signal. Then delta of t response is the h of t and d by dt of, and the u of t response is the s of t. So impulse response is the derivative of the step response. So if you know one thing, getting the other thing is a very fraction of second. So we can say that the impulse response is the derivative of the step response, or the step response is the integration of the impulse response. You can say it anything. So impulse response is the derivative of the step response, or the step response is the integration of the impulse response. So if you know one thing, getting the other thing is a very piece of cake. So this is what I want to tell you. So if you know the input relation, you can get the similarly the other operations also you can easily get. So if you know the input relations, then getting the output relations is also same. This is in the time domain. Now let's go for the discrete time domain. This is the continuous time domain. Now let's go for the discrete time domain. How it is going to happen. So this is the discrete time domain. So this is the system. If the input is u of n, the output is s of n. If the input is delta of n, the output is h of n. Right? So now how I can write u of n? So u of n is that in the integration of the delta of n. So u of n is equal to sigma k is equal to minus infinity to n delta of k. Right? So u of n is equal to sigma k is equal to minus infinity to n delta of k. Then the response is also same. U of n response is s of n. Sigma k is equal to minus infinity to n and delta of k response is equal to h of k. Therefore, we can say the step response. The step response is the absolute. Yes, we can say that you can say like this: s of n is equal to sigma k is equal to minus infinity h of k. If you can write in the reverse also, delta of n. So how you can write delta of n? Delta of n is equal to u of n minus u of n minus 1. Delta of n is nothing but u of n minus u of n minus 1. Then what is delta of n response? H of n. So what is u of n response? S of n. U of n minus 1 response is s of n minus 1. Because the system is an LTI system. So h of n is equal to s of n minus s of n minus 1. So you can see clearly here. If you know one thing, you can get the other thing in a very fraction of second. So this is for LTI system. The input is delta of t, then output is h of t. The input is u of t, then output is s of t. For the same LTI system, but it is a discrete in nature. If the input is delta of n, the output is h of n. The input is u of n and the output is delta of n. So finally, let me write the simple manner. So let me write here, h of t is the d by dt of the s of t, right? Then s of t is the integration of tau is equal to minus infinity to t h of tau into d2. This is in the continuous time nature. Now let's go for the discrete time nature. So s of n is equal to sigma k is equal to minus infinity to n h of k. Similarly, h of n is equal to s of n minus s of n minus 1. So if you know these things, you can easily get here. So this is the continuous time domain nature and this is the discrete time domain nature. So if you know delta of t, this is if you know s of t, you can get the h of t by this relation. If you know h of t, you can get the s of t by this relation. So if you know s of n, with the help of this relation, you can get the value of h of n. If you know h of n, with the help of this relation, you can get the value of s of n. So therefore, finally, what I am trying to tell you very simple. So if you know h of t or h of n, then we can get the output in a very easy manner. Means we can know each and everything regarding the output. I already told you the system properties that we are going to analyze only with the help of the impulse response. So if you know the impulse response, unit impulse response, then we can tell each and every property of the LTI system. So we can say, if you know the impulse response, just by seeing the impulse response, we can tell what are the properties which are going to satisfy by this LTI system. So listen carefully. If you know the impulse response of a LTI system, then we can tell what are the properties that are going to satisfy by the LTI system, whether the system is stable or not, whether the system has memory or not, or whether it is a causal or non-causal system. All these things, or whether it is immutable or non-mutable, all these things we can analyze. So therefore, the system response, it can be better tested with the unit impulse as the input signal. So listen carefully. Finally, I can say the system response can be tested better with the unit impulse input signal. Means if you do the input as the unit impulse signal, we are going to get the output as h of t. If you know h of t, you can get each and everything regarding the LTI system. What are the properties that are going to satisfy by those systems? All these things that we are going to know with the help of this signal. So this is the point always you have to keep in mind. So now let's go for the another question. The next question, which is, we can say, what is the Laplace transform of the e to the power of minus 2t into u of t? So we have to find what is the Laplace transform of the e to the power of minus 2t into u of t that we need to figure out. So the correct solution of this question is 1 by s plus 2 is the correct solution of this question. So let's solve this numerical. So basically, I have already told you e to the power of minus at into u of t as the Laplace transform 1 by s plus a. So a is equal to a, this option can simplify. So we are going to get 1 by s plus 2. So this is the correct solution of this question. But let us do some more further analysis. So we have to find what is the Laplace transform of e to the power of minus 2t into u of t that we need to figure out. As I already told you, we know that. So we know that e to the power of minus at into u of t as the Laplace transform 1 by s plus a. So I already told you e to the power of minus at into u of t as the Laplace transform 1 by s plus a. So here a is equal to e to the power of minus 2t into u of t as the Laplace transform. In place of a substitute, then we are going to get 1 by s plus 2. So this is the Laplace transform for this signal. So let us give me some formulas. I already told you that for f of t, the Laplace transform is f of s. For e to the power of minus 18 to f of t is the Laplace transform f of s plus a. Here minus means here plus. Here plus means here minus. As I already told you that e to the power of minus 18 to f of t as a Laplace transform f of s plus a. Right? Here plus means here minus means here plus. F of t minus is nothing but it has Laplace transform e to the power of minus a s into f of s. Here minus means here also minus. Here plus means here also plus. Similarly, f of at is the Laplace transform 1 by mod a into f of s by a. A can be positive, a can be negative. Similarly, t to the power of n into f of t is the Laplace transform minus 1 over the power of n into nth derivative of f of s with respect to s. T to the power of n into f of t is the Laplace transform minus 1 over the power of n into nth derivative of f of s with respect to s. Similarly, every derivative of f of t with respect to t is that we know it as Laplace transform is the power of n into f of s. There are no extra terms because it is a bilateral transform. If it is a unilateral transform, there will be extra terms are there. So this will always you have to keep in your mind. So f of t is Laplace transform f of s. E to the power of minus 18 into f of t is Laplace transform f of s plus a. So here minus means here plus means here minus. F of t minus a as the Laplace transform. E to the power of minus a into f of s. So here minus means here also minus, f plus means here also plus. F of et is a Laplace transform 1 by mod a into f of s by a. And t to the power of n into f of t is a Laplace transform minus 1 to the power of n into nth derivative of f of s with respect to s. And nth derivative of f of t with respect to t as a Laplace transform is the power of n into f of s. So this is a case of the bilateral transform. If there is a unilateral transform, means extra terms are going to get present, means initial conditions are going to get present. So let me give you some important point here. So I want to give you some important point. See, I have already told you one important point. For u of t, what is the Laplace transform? 1 by s. And the real part of s is greater than 0 because it is a right signal. So our answer is to the right side. This the real part of s is greater than 0. Right? So this one is I already told you. So now, e to the power of minus 80 into u of t as a Laplace transform, which is wherever s is there, replace s by s plus a. So what are you going to get? S plus a. Here also replace s by s plus a greater than 0. So what is the meaning of this one? Real part of s plus a means s is equal to sigma plus j omega plus a. What is the real part means sigma plus a. So sigma plus a greater than 0. So sigma greater than minus a. Right? So understood? So this is now you can write sigma greater than 0 and you can get this sigma greater than minus a. ROC is going to be changed, right? So now e to the power of minus 20 into u of t as a Laplace transform 1 by s plus 2 with an ROC sigma greater than minus 2. Right? Suppose if they are asking the ROC means sigma greater than minus 2. So always remember, if f of t as the Laplace transform f of s with an ROC real part of s, then e to the power of minus 80 into f of t as the Laplace transform f of s plus a with an ROC replace s by s plus a real part of s plus a. So this one always you have to keep in mind. Suppose if they are asking the ROC means this is the t. So e to the power of minus 20 into u of the Laplace transform into s plus 2 with an ROC sigma greater than minus 2. So this is the extra point that you have to keep in mind. So this is the correct solution of this question. So now let's solve the other question. See the question here. An anti-aliasing filter is. An anti-aliasing filter is. Option A, an analog filter. Option A, a digital filter. Option C, can be both analog or digital. Option D, none of the above. So there are 4 options. Option A, it is always an analog filter only but not a digital filter. An anti-aliasing filter is always a analog filter only. An anti-aliasing filter is always an analog filter only is the correct solution of this question. So an anti-aliasing filter is always an analog filter is the correct solution of this question. So why it is like this? Now we will discuss here. An anti-aliasing filter is always an analog filter only. So an anti-aliasing filter is always an analog filter only means it is always an analog filter but not a digital filter. So anti-aliasing filter is always an analog filter only. So why it is like this? Now we will discuss. Anti-aliasing filter is also called as the AF, which are always analog filters as they process the signal before it is applied. AF is a filter used before a signal sampler to restrict the bandwidth of a signal to satisfy the Nyquist channel sampling theorem over the band of interest. So what is the meaning of this one? Suppose, let me tell you, this is the we can say anti-aliasing filter. It is basically a low pass filter. Low pass filter means it will have the cutoff frequency from omega c to minus omega c. Suppose this is the analog filter. The input is analog signal, which is having a range of frequency from omega 1 to minus omega 1. So generally, in the real world, the frequencies are very, very huge. Omega 1 is very, very high. So in the practical world, omega 1 is very, very high. So omega 1 is very, very high. But we don't want all these frequencies. We need only certain amount of frequencies. We don't want all these frequencies. So we are going to cut down the signal to only those frequencies that we really require. So I want only those signals which are up to having a frequency only up to omega c only I need. I don't need more than this one. So, but in the practical world, the analog signal will have lot of frequencies. It has lot of frequencies. But I want only those frequencies which are in this limit from 0 to omega c only I want to figure out. So output what we are going to get? We are going to get a signal which is having a frequency only from 0 to omega c. So this is a figure you are going to get from 0 to omega c, 0 to minus omega c. Only this part you are going to get this. The other part is clipped off. The other part is clipped off. Only this part we are going to get. So this is a basic nature of the anti-aliasing filter. Means it is going to keep only those frequencies which are required, but not the other frequencies. But practically the analog signal will have a lot of frequencies, but we don't need all those frequencies. We only require only certain frequencies only we are going to require. So that is the reason always this anti-aliasing filter we are going to keep before the analog signal in order to get the signal which is having the frequencies which are useful for our purpose only. So this is called as the band limited signal, means which is having a finite amount of band. So now we are going to apply to a sampler and the quantizer. Then we are going to get a digital signal. Output we are going to get a digital signal. So what I have assumed, omega 1 is always greater than omega c. Because I have already told in the practical world, omega 1 is very high because it will have a lot of frequencies. So omega 1 is very high when compared to omega c. So this is happens only with the help of this AEF is basically analog filter. As you can see, this is nothing but an analog filter. This is nothing but it is always designed with only an analog filter. So therefore we can say as it is going to design with the analog signal, so definitely it should be an analog filter only. As this filter is going to deal with the analog signal, so definitely this is the analog filter only. So therefore we can say an anti-aliasing filter, it is always an analog filter only. Basically we can also call this as a ideally low pass filter also we can say. So these are the anti-aliasing filters which are always analog filters, and they are going to process the signal before it is applied. So basically they are going to process the signal in order to cut down the high frequencies to low, in order to basically have a signal of having only a certain amount of frequencies, but not on each and every frequency. It is going to have only a certain amount of frequencies, but not every frequency. So that is the reason it is going to process the signal of infinite bandwidth to a finite bandwidth. AF is a filter which is used before a signal sampler in order to restrict the bandwidth of a signal to satisfy the Nyquist sampling theorem over the band of interest. So in simple words I can say like this. This anti-aliasing filter is basically a low pass filter and is always going to deal with the analog signals. Definitely it is an analog filter, and it is going to limit the bandwidth of the original analog signal to a finite amount of bandwidth. That is the basic agenda of this analog filter. It is going to process the input analog signal. So definitely it is always designed with only analog. It is always an analog filter because it is always going to deal with the analog signals as the input. So finally I can say the anti-aliasing filter is always an analog filter because it is going to deal with the analog signals in order to cut down in order to limit the bandwidth from huge amount of bandwidth to a finite amount of bandwidth. This point always you have to keep in your mind. So this is the correct solution of this question. Now we are going to discuss another question. See the question here. Find the RMS value of the signal. So basically they are given some signal x of t is equal to 5 into cos of 50t plus 5 by 3. So for the signal we have to find what is the RMS value we need to figure out. So the four options, option D under root over 12.5 is the correct solution of this question. So let's solve this numerical. So what is the signal x of t? X of t is equal to 5 into cos of 50t plus 5 by 3. So basically this is in the format of the, so this is in the format of the EM into cos of omega t plus some theta is there, right? So then what is RMS value? RMS value is something but peak value by root 2, whether it is a sine wave or whether it is a cos wave. The RMS value is something but peak value by root 2, the peak value is 5, so 5 by root 2. So what I will do? I will do in the other form, which is under root over 5 square by 2, and here which is 5 by root 2, right? Because here root 2 are going to cancel, therefore we are going to get same thing 5 by root 2, or you can say under root over 25 by 2 also you can write. So 25 by 2 is nothing but 12.5. So root over 12.5 you can write, or either 5 by root 2 also you can write. Any of the concept is same. So the RMS value of the signal is nothing but T equal by root 2. Finally we are going to get this root over 12 by 12.5 or 5 by root 2. So we know that for x of t is equal to am cos omega t plus theta, what is the RMS value, which is something like peak value by root 2, peak value by root 2. So this one always you have to keep in your mind. So this is the correct solution of this question. So now we are going to solve another question. See the question here. The question says that evaluate the function, which is integration of 0 to infinity t square into delta of t minus 3 into dt. So evaluate the function integration from t is equal to 0 to infinity t square into delta of t minus 3 into dt that we need to figure out. So what are the four options? Option D, 9 is the correct solution of this question. So let's solve this numerical. So the integration of t is equal to 0 to infinity t square into delta of t minus 3 dt that we need to figure out. So I've already told you the basic formula. We know from the shifting property, which is integration of t is equal to minus m to plus m t f of t into delta of t minus t naught dt, which is equal to f of t naught. As I've already told you, this isn't carefully. This t naught should lie between these limits. So it should lie in the integration of these limits. Suppose if this t naught is not lying, means its value is equal to 0. As I've already told you, this delta of t signal, this signal should lie between these limits of integration. So if it is lying, means this is a value. Suppose if it is not lying, means its value is equal to 0. As I've already told you. So now here t naught is equal to 3. So this delta of t minus 3 is going to present at t is equal to 3. It's a shifted version of delta of t by 3 units. So it is going to lie at t is equal to 3. So at t is equal to 3, we are doing integration from 0 to infinity. Yes, it is going to lie in the integration. So t is equal to 3 is going to lie between 0 to infinity. So substitute in place of this is f of t. F of t is something like t square and t naught is equal to 3. We substitute here. So 3 whole square is something like 9. You are going to get here because this signal is going to lie in the limits of the integration. So in the limits of the integration, so this value is something like f of t naught. The t naught is equal to 3 and we substitute here 3 square is equal to 9. So integration of t is equal to infinity square into delta of t minus the dt is equal to in the place of t substitute f of t is equal to t square. So in the place of t substitute t is equal to 3 and in simplify we are going to get t square which is equal to 9. So 9 is the correct solution of this question. So always keep in your mind only one thing that I am trying to tell you, which is something that simply whenever the integration of t is equal to minus m to plus m t f of t into delta of t minus t naught dt is always equal to f of t naught. If the impulse signal should lie in the limits of the integration, then only its value is equal to f of t naught. Suppose if it is not lying, means its value is equal to 0, as I already told you. So in this case, we can say the solution is 9 is the correct solution of this question. So like this, always you have to keep in your mind the shifting property. The shifting property is nothing but simply I can say integration of t is equal to minus m to plus m t f of t. So f of t. So f of t into delta of t minus t naught into dt is equal to f of t naught. So this formula always you have to keep in your mind. So now this is the correct solution of this question, right? So now let's go for the another question. The question says that now find the fundamental period t of the following continuous signal. So find the fundamental period t of the following continuous signal. So basically they have given some continuous time signal and they are asking what is the fundamental time period we need to figure out for this continuous time signal. X of t is equal to 20 into cos of 10 pi t plus pi by 6. So for this continuous time signal, we have to find what is the fundamental time period we need to figure out. So out of the four options, option D 1 by 5 seconds is the correct solution of this question. So let's solve this numerical. See, what is the answer here? X of t is equal to 20 into cos of 10 pi t plus pi by 6. So this is, so then what's the value of omega? Omega or omega naught? You can take it anything. Omega naught is something but 10 pi, or sometimes some books they take omega and some books they take omega naught. Omega which is same. Omega naught is equal to 10 pi. I've already told you this in the format of the A cos of omega t plus theta, or omega naught or omega which is equal to 10 pi. Omega naught is something but 2 by t naught which is equal to 10 pi. So if you simplify, what is t naught? 2 by 10 pi. 5 by cancels, 2 on the 2 5s are. So therefore you are going to get 1 by 5. So what is the fundamental time period which is equal to 1 by 5 seconds? So omega naught is follows a fundamental angular frequency and its unit is radians per second. And t naught is follows a fundamental time period. Fundamental time period. Then I should write here time period. Not fundamental period. It is a time period. Fundamental time period and its unit is second. So omega naught is nothing but fundamental angular frequency and its unit is radians per second. And epsilon naught is called as a fundamental time period and its unit is second. Then what is f naught? F naught is nothing but fundamental frequency. So f naught is called as the fundamental frequency, and its unit is hertz. And its unit is hertz. F naught is equal to 1 by P. They have not asked for the fundamental frequency, but you have to maybe formula, right? So always remember, omega is equal to 2 pi by P or 2 pi into F. And omega is called as the angular frequency and its unit is radians per second. And t is called as the time period and its unit is second. And f is called as the frequency and its unit is hertz. Here basically we are going to say it's a fundamental, so we have to keep fundamental for each and every word. Omega is called as the fundamental angular frequency and its unit is radians per second. And t is called as the fundamental time period and its unit is second. And f is called as the fundamental frequency and its unit is hertz. So in this question they are asking for the fundamental time period and its value is 1 by 5 second. So this is the correct solution of this question. So now we are going to solve the another question. See the question here. The question says that for an energy signal g of t and its time shifted version g of t minus capital T. Yeah. So for an energy signal g of t and its time shifted version, which is g of t minus capital T is. So basically what they are asking is very simple. They are asking there is a signal g of t is there. So now how did the shifted version of the signal g of t by g of t minus capital T. So we are going to g of t minus capital T. So what is the relation between them? Which is option B. Amplitude spectra are identical but their phase spectra are different. So for g of t and g of t minus capital T, both these have the same amplitude spectra. Or we can say amplitude spectrum are identical but the phase spectrum are different. So this is the correct solution of this question is for g of t and g of t minus capital T, for both these things, the amplitude spectrum is same, whereas the phase spectrum is different. So now we'll discuss why it is like this. So option B is the correct solution of this question. So now we'll discuss something more about this one. So now you can see for g of t. For g of t, what is the Fourier transform? G of omega. G of omega is basically a complex number. So it has a magnitude as well as an angle. So complex number means real part and image alpha. In rectangular format, in the polar format, magnitude and the base angle. So magnitude of g of omega into e to the power of j, base angle of g of omega. We can write like this, or either you can also write like this also we can write. Either you can write like this also, mod of g of omega and phase angle of g of omega also you can write. It's up to you. For g of t minus capital T, for g of t minus capital T, what is the Fourier transform? See, I already told you an important formula. You have to always keep in your mind. So for f of t, the Laplace transform is f of s. F of s. Then for f of t minus a, what is the Laplace transform? The Laplace transform. What is the Laplace transform? E to the power of minus as into f of s. Suppose if you want to find what is the Fourier transform, replace s by j omega. So we are going to get minus a j omega. F of omega. Instead of j omega, so it will be say. Or what you are going to get e to the power of minus a omega j f of omega. Right? So for this the Fourier transform is f of t minus a. Here, what is a? A is nothing but capital T. So capital T and it is nothing but j. So then what is the Fourier transform that we are going to get? In place of a, substitute here t. So minus p omega j. In place of f, substitute j. So j of omega. So this is what we are going to get. Same thing. So same thing everything. So same thing everything. E to the power of minus j omega t into g of omega. Same thing. E to the power of minus j omega t, you can write in the transform, it is same. So therefore we are going to get like this. E to the power of minus j omega t into g of omega. So if you Laplace transform, getting this Fourier transform is a very piece of t. So therefore now I want to write in the magnitude and the phase angle. So what is the magnitude? If you want to find what is the magnitude, magnitude of A into B is equal to magnitude of A into magnitude B. This magnitude is always equal to 1. So only you are going to get this magnitude is equal to magnitude of j of omega. And what is the phase angle? Phase angle summation of these two phase angles. it is e to the power of j of s angle of g of omega plus minus omega t. This angle is minus omega t. So this is what we are going to get. So now, if you see clearly, the magnitude spectrums are identical, but the phase spectrum are different. Here only s angle of g of omega, but here s angle of g of omega minus omega t. So you can see the phase spectrums are different, but the magnitude spectrums are identical. So g of omega is equal to mod of g of omega into e to the power of g of s angle of g of omega, and e to the power of minus g omega, e to the power of minus g omega t into g of omega. The magnitude part is lambda of g of omega into e to the power of j of s angle of g of omega minus omega t. So these two angles are going to get added. Magnitudes are going to get multiplied and phase angles are going to get added. I am already told in the polar format. So you can see both these things have the same amplitude spectrum, but the phase spectrums are different. G of t and g of t minus capital T have the same amplitude spectrum, but the phase spectrums are different. So g of t and g of t minus capital T have same amplitude spectrum but different phase spectrum. So I can say simply these two have the same amplitude spectrum but the phase spectrums are different. So now we will discuss some information regarding the signal, their Fourier transform, and some information regarding this one. Suppose if a signal is an energy signal means energy is equal to finite, or we can say the signal is absolutely integrable. Then the Fourier transform is a well-defined Fourier transform. It is defined for each and every value of the omega. Then you can use the direct formula, the Fourier transform formula. What is the Fourier transform formula for the f of t? F of omega is equal to integration of t is equal to minus t, f of t into e to the power of minus omega t into dt. So there we can use f of t and try to use the direct formula in order to get the Fourier transform. Suppose if a given signal is a power signal means that, so what's the meaning of power signal? Power signal is nothing but energy is equal to infinity and the power you are going to get a finite value. Then we can say that given signal is set to the power signal means it is not absolutely integrable. The signal is not absolutely integrable. But the Fourier transform, it is called as a linearly defined Fourier transform. Means it is defined only for a few values of omega, but for other values omega it is not defined. Means it tends to infinity. So we cannot use direct formula. We cannot use direct Fourier transform formula, but in this case, we can use the properties. The properties that we know. We can use them in order to get the Fourier transform. So use only the properties, but not direct Fourier transform formula in order to get the Fourier transform for this signal, as I already told you. Suppose if a given signal is not an energy signal, it is not a power signal, then Fourier transform is not defined. This is also not defined. So what I am trying to tell you, if a given signal is an energy signal means it is absolutely integrable, then the Fourier transform is well defined, means it is defined for each and every value of omega, and you can use the direct Fourier transform formula in order to get the Fourier transform. Take the f of t and get the value of f of omega with the help of Fourier transform. But if a given signal is a power signal means energy is equal to infinity and the power is equal to finite, means the signal is not absolutely integrable. Even though the Fourier transform is going to get defined, but it is a linearly defined Fourier transform means it is not defined for certain values of omega because it is going to tend to infinity. So in that case, you cannot use the direct Fourier transform formula, but you can use the properties in order to get the Fourier transform for these type of power signals. Suppose if a given signal is neither energy signal, it is neither power signal, then the Fourier transform is not at all defined for those type of signals. So this table always you have to keep in your mind. So just by seeing a signal, we can say whether the Fourier transform is going to present or not. Just by seeing a signal only, we can say information. So what is our Fourier transform formula? I already told you for x of t. What is the Fourier transform formula? X of omega is equal to integration of t is equal to minus t x of t into e to the power of minus j omega t into dt, as I already told you, right? Then if you want, see, if you know x of t, you can get the x of omega with the help of this formula. And what is the vice versa? X of t is equal to 1 by 2 pi integration of omega is equal to minus t x of omega into here minus means now keep it place e to the power of j omega t into d omega, because we are doing with respect to omega, so you have to keep it d omega. The above are called as direct Fourier transform formula. This is called the Fourier transform formula. So keep your x of t and get the value of x of omega only if it is an energy signal. If it's a power signal means don't use this formula. Use the properties. So if a given signal is an energy signal, then directly use this Fourier transform formula in order to get the Fourier transform of the signal. Suppose if a given signal is a power signal, then you don't use this formula, but use the properties in order to get the Fourier transform. So this is what I am trying to tell you. So always remember, x of omega is equal to integration of t is equal to minus 70% x of t into e to the power of minus j omega t into dt. Here x of t is equal to 1 by 2 pi integration of omega is equal to minus 70% x of omega into e to the power of plus j omega t into d omega. So these point always going to keep in your mind. So this is a correct solution of this question. So now we are going to solve another question. See the question here. Two orthogonal signals S1 of t and S2 of t satisfy the following relation. Suppose if S1 of t and S2 of t are the orthogonal signals, then what is the condition that they are going to be satisfied that we need to figure out. Suppose if S1 of t and S2 of t are the orthogonal signals, then what is the relation that they are going to get satisfied that we need to figure out. So we can say that S1 of t and S2 of t are the orthogonal signals. If these are orthogonal signals, then what is the condition that they are going to get satisfied that we need to figure out. So the four options, option A is the correct solution of this question, which is integration over the one time period S1 of t into S2 of t dt is equal to 0, then we can say these two signals are called as orthogonal signals in a time from 0 to capital T. In this time, these two signals, if this is a condition is going to be satisfied, then we can say these two signals are orthogonal in this time from 0 to T. So integration of 0 to T, S1 of t into S2 of t dt is equal to 0, then we can say these two signals S1 of t and S2 of t are orthogonal in this time period. So if this condition is satisfied, then we can say these two signals are orthogonal in this time period. So integration of 0 to capital T, S1 of t into S2 of t dt is equal to 0, then we can say these two signals are called orthogonal signals in this time period 0 to t. So now we'll discuss something more about this one. So two orthogonal real signals S1 of t and S2 of t, they are going to satisfy the following relation, which is 0 to t, S1 of t into S2 of t into dt is equal to 0. If two orthogonal complex signals S1 of t and S2 of t, they are going to satisfy the following relation, which is 0 to capital T, S1 of t into S2 of t complex conjugate into dt is equal to 0. So here S1 of t and S2 of t are the two orthogonal real signals, whereas here S1 of t and S2 of t are the two orthogonal complex signals. Real signals means this is the condition, complex signals means this is the condition. This one I have already told you in the class also. So listen carefully. If there are two signals S1 of t and S2 of t, these are real orthogonal signals. In the condition that they are going to satisfy, which is 0 to t, integration of 0 to t, S1 of t into S2 of t dt is equal to 0 means in this time period, these two signals are called as orthogonal signals. Similarly, if S1 of t and S2 of t are the two orthogonal complex signals, then the condition that they are going to satisfy is integration of 0 to t, S1 of t into S2 of t complex conjugate dt is equal to 0. So this one always you have to keep in your mind. So finally, I can say if S1 of t and S2 of t are the two orthogonal real signals in a given time period of t, then the condition that they are going to satisfy, which is integration of 0 to t, S1 of t into S2 of t dt is equal to 0. Similarly, the two signals S1 of t and S2 of t is a complex orthogonal signals in a time period of 0 to t, then they are going to satisfy the condition, which is integration of 0 to t, S1 of t into S2 of t complex conjugate dt is equal to 0. So finally, I can say if there are two orthogonal real signals S1 of t and S2 of t, and which are basically similar carefully, finally I am going to tell you if there are two real signals S1 of t and S2 of t, they are orthogonal in a time period of 0 to t, then the condition that they are going to satisfy, which is integration of 0 to t, S1 of t into S2 of t dt is equal to 0. Similarly, there are two complex signals S1 of t and S2 of t. If they are orthogonal in a time period 0 to t, then the condition that they are going to satisfy, which is integration of 0 to t, S1 of t into S2 of t complex conjugate dt is equal to 0. So finally, I can say that there are two real signals S1 of t and S2 of t, and they are orthogonal in a time period of 0 to t, then the condition that they are going to satisfy, which is integration of 0 to capital T, S1 of t into S2 of t dt is equal to 0. Similarly, there are two real signals S1 of t. Similarly, there are two complex signals S1 of t and S2 of t, and they are orthogonal at a time of 0 to t. Then the condition that they are going to satisfy, which is integration of 0 to t, S1 of t into S2 of t complex conjugate dt is equal to 0. These things are already I told you in my classes. So in this case, they are taking only the real signals. So this is the condition. As you can see clearly, integration of 0 to t, s1 of t into s2 of t dt is equal to 0. So this is the correct solution of this question. We are going to discuss another question. See the question here. The output omega of n of the system shown in the figure is. The output omega of n of the system shown in the figure is. So basically, they are given two blocks. They are cascaded. For the first block, the input is x of n and output is y of n. For the second block, the input is y of n and output is y of omega of n. So they are given the relation. For the first block, the relation with the input and the output, which is y of n is equal to sigma k is equal to minus m to n x of k. For the second block, the relation between the input and output, which is omega of n is equal to y of n minus y of n minus 1. So basically in this question, we have to find what is the relation of the omega of n with respect to x of n that we need to figure out. So the four options. Option A, x of n is the correct solution of this question, means omega of n is the but x of n is the correct solution of this question. So let's solve this numerical. So this is the same figure I have drawn. So this is the first block and this is the second block. For the first block, the input is x of n and the output is y of n. For the second block, the input is y of n and the output is omega of n. For the first block, the relation between the input and the output, which is y of n is equal to sigma k is equal to minus m to n x of k. And for the second block, the relation between the input and output, which is omega of n is equal to y of n minus y of n minus 1. So now we have to write what is omega of n in terms of x of n. We need to write here. So here y of n is nothing but sigma k is equal to minus m to n x of k. Already they have given. And what is omega of n? Omega of n is nothing but y of n minus y of n minus 1. Already they have given. Omega of n is nothing but y of n minus y of n minus 1. So y of n is nothing but this value. So sigma k is equal to minus m to n x of k minus. What is y of n minus 1? Wherever n is there, replace by n minus 1. Then you are going to get sigma k is equal to minus m to n minus 1 into x of k. So this is a y of n. And what is y of n minus 1 expression? Wherever n is there, replace n by n minus 1. Therefore, you are going to get sigma k is equal to minus m to n minus 1 x of k. So this of these two values here is a y of n expression and this is a y of n minus 1 expression. So now we need to do the subtraction of these two things. So this one I can write like this, up to n minus 1 plus nth term. This I can write up to n minus 1 terms plus nth term. Is sigma k is equal to minus m to n minus 1 x of k plus x of n. This I can write up to summation of n minus 1 terms plus nth term. Nth term is x of n. So minus this one. So these two are same, but opposite negative sign is there. So these two are going to get cancelled. So only thing that we are going to remain is x of n. So omega of n is nothing but x of n. So therefore, what I have did basically, here first I got the y of n, then I tried to find the value of y of n minus 1. I did the subtraction of these two things. Then this is nothing but up to n terms plus n term. So these two are going to get cancelled and only the nth term that you are going to get remain. So omega of n is nothing but x of n. So this is the correct solution of this question. So now what we are going to do is we are going to solve another question. See the question here. Which one of the following is a periodic signal? So which one of the following is a periodic signal? So in this question they are given four options, and in the four options they are asking out of these four signals, which signal is a periodic signal that we need to figure out. So option A, x1 of t is equal to 2 into e to the power of j of t plus pi by 4 into u of t. Option B, x2 of n is equal to u of n plus u of minus n. And option C, x3 of n is equal to sigma k is equal to minus m to infinity delta of n minus 4k minus delta of n minus 1 minus 4k. And option D, x1 of t is equal to e to the power of minus 1 plus j into t. So out of this, which signal is a periodic signal that we need to figure out? So option C is the correct solution of this question. So let's solve this numerical. So what is the option A? They have given x1 of t is equal to 2 into e to the power of j into t plus 5 by 4 into u of t. So this is the first signal they have given. So now we need to check whether this is a periodic signal or a non-periodic signal that we need to figure out. So this signal is defined only from t is equal to 0 to t is equal to infinity because u of t is there, right? As u of t is there, this signal is given defined only from t is equal to 0 to t is equal to infinity. So it is a aperiodic or non-periodic signal because the signal is They only from t is equal to 0 to t is equal to infinity. So for negative cycle, it is not there. Periodic signal means it should present for all the time. The cycle should repeat. As the signal is not present and for the negative values of t, so by default we can say it is a aperiodic signal or non-periodic signal. What's the meaning of periodic signal? Periodic signal means it should present for all values of time and the cycle should repeat after a certain amount of time. In this case, for negative values of t, it is not present. It is not even present. So default we can say it is a aperiodic signal or the non-periodic signal. Now let's go for the option B. X2 of n is equal to u of n plus u of n minus 1. And now I am going to draw the waveform for this signal. It's a discrete time signal, right? So now what I am going to do, I am going to draw for each value of n. So for n is equal to 0, if we substitute what we are going to get, u of 0 plus u of minus 0 plus u of 0 plus u of 0 is equal to u of 0. So u of 0 is equal to 1. So 3n is equal to 2 we are going to get. So therefore its value is equal to 2 for n is equal to 0. So here its value is equal to 2. So like this we are going to get its value is equal to 2. But n is equal to 1. We substitute in what we are going to get u of 1 plus u of minus 1. U of n is 1 and u of minus 1 is 0. So 1 plus 0 is equal to 1. So this value is equal to 1. Similarly, if we substitute for n is equal to 2, we are going to get its value is equal to 1. If we substitute for n is equal to 3, we are going to get its value is equal to 1. And similarly goes on. Similarly, if we substitute n is equal to minus 1, then what we are going to get u of minus 1 plus u of 1. So u of minus 1 is 0 and u of 1 is 1. So here you are going to get its value is equal to 1. Similarly, u of minus 2 nothing but you are going to get its value is equal to 1. And u of minus 3, so we are going to get its value is equal to 1. So we can say like this we are going to get here. So like this we are going to get for n is equal to 0, its value is equal to 2. And for remaining all other values, its value is equal to 1. So what we can get? So we can get like this. Its value is equal to 2 for n is equal to 0. And its value is equal to 1 for n not equal to 0. We can write like this. So definitely this is a periodic signal or non-periodic signal because there is nothing like repetition. There is nothing like repetition. There is a sequence of numbers are not repeating. It is not repeating. So default we can say it is a periodic signal or non-periodic signal. As a sequence of numbers are not repeating. So definitely we can say this is a periodic signal or non-periodic signal. Now let's go for the option C. The option C is S2 of n is equal to sigma k is equal to minus into percent of a delta of n minus 4k minus delta of n minus 1 minus 4k. So now I need to draw this waveform. I want to comment on the whether it is a periodic or aperiodic. So this is the x3 of n, right? So now if I substitute k is equal to 0, then what we are going to get here? Delta of n minus delta of n minus 1. So delta of n is nothing but here. This value is 1. Delta of n minus 1 is here. But there is a minus 1 here. Here plus 1 minus 1. So plus 1. Here minus 1. So here it is plus 1 and here it is a minus 1. Similarly, if you substitute k is equal to 1, substitute k is equal to 1, then what you are going to get? Delta of n minus 4 plus delta of n minus 4 minus delta of n minus 5. N minus 1 minus 4 is n minus 5 is here. At n is equal to 5, we are going to get its value is equal to minus 1. Again, same thing is going to repeat. Suppose if you substitute k is equal to minus 1, then what you are going to get? Delta of n plus 4. Delta of n plus 4 is a number that minus 4 is going to present its value is equal to 1. If you substitute k is equal to minus 1, we are going to get n minus 1 plus 4, which is n plus 3. N plus 3 means is going to present at n is equal to minus 3 and its value is equal to minus 1. So plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. If you see the sequence, what is going to get here? Here plus 1 you are going to get. Here minus 1, then 0, then 0. Again plus 1, again minus 1, then 0, again 0. Similarly here also plus 1, so here it is a plus 1, here it is a minus 1, then 0, then 0. So what is the sequence here? The sequence is 1, minus 1, 0, 0. Again repetition, again repeat, again it is repeating. So plus 1, minus 1, 0, 0. Again repeat, plus 1, minus 1, 0, 0. Again repeat, plus 1, minus 1, 0, 0. Again repeat. So this is a periodic signal of period. What is the sequence of numbers are there? 1, 2, 3, 4, and 4 are there. And if this 4 out of the sequence is going to get repeat. So this is a period of the signal. So this is the period of the signal. N is equal to 4. Only this 4 sequences are there. When those 4 sequences are there, after that it is going to repeat. So this is called as the period, which is the number of samples after which the sequence is going to repeat. Is something like period. So cancel. So 1 sample, 2 sample, 3 sample, 4 sample. After that, the signal is going to get repeated. So this is the period of the signal. So what is the period of the signal? It is nothing but 4. N is equal to 4. So this is a periodic signal of period N is equal to 4 because after the samples, signal is going to get repeated. So this is the period of the signal. So now let's go for the option D. What is option D? S of t is equal to the power of minus 1 plus j into t. So if I simplify what I am going to get, I can write like this, right? Which is equal to e to the power of minus t plus jt means e to the power of m plus n is equal to e to the power of m into e to the power of n. So e to the power of minus t into e to the power of jt. So e to the power of jt is a periodic signal. What is the period here? For e to the power of e to the power of j omega t. What is the period here? 2 pi by omega. For e to the power of jt, omega is equal to 1 means the period is 2 pi. This is a period. This is a period, right? So period. So here omega is equal to 1 means the period is equal to 2 pi. So this is a periodic signal of period 2 pi. For e to the power of minus e to the power of minus 2 is nothing but it's a periodic signal. It's a decaying signal. Or it is a decaying signal. So definitely we can say it is a decaying signal. Decaying signal means it is not repeating anywhere. It is not repeating anywhere. Definitely it is a periodic signal. So whenever you are going to multiply these two things, the overall thing is also again a periodic signal. So whenever you are going to multiply a periodic signal to a periodic signal, the resultant signal is always a aperiodic signal. So the signal is a aperiodic or the non-periodic signal. So whenever you are going to multiply the aperiodic signal to a periodic signal, then the resultant signal is always again a periodic signal or non-periodic signal. So this is the correct solution of this question. So therefore we can say only option C is a periodic signal with a period of 4. So this is the correct solution of this question. So now we are going to solve another question. See the question here. If the input-output relation of a system is y of t is equal to integration of t is equal to minus ft t 2t x of tau d tau, then the system is. So basically they have given some system between the input and output. What is the relation? They have given certain relation between the input and the output, which is y of t is equal to integration of tau is equal to minus ft 2t x of tau d tau. Tau is equal to minus ft 2t. Then what is the system we need to figure out? So option A, linear, time invariant, unstable. Option B, linear, non-causal, unstable. Option C, linear, causal and time invariant. And option D, non-causal, time invariant and unstable. So the 4 options, option B is a linear system, non-causal system, and the unstable system is the correct solution of this question. So let's solve this numerical. So you can see what is the input output relation of a certain system. Y of t is equal to integration of tau is equal to minus 72 2t x of tau d tau. So now we have to check all the properties like linearity property, time invariant property, causality property, and instability property. All these 4 properties we are going to check in a very detailed manner. The first thing is I am going to check the linearity property for the system. If the input is x1 of t, then what is the output? y1 of t is equal to integration of tau is equal to minus 72 2t x1 of tau d tau. For the same system, the input is x2 of t, then the output which is y2 of t is equal to integration of tau is equal to minus 72 2t x2 of tau d tau. For the same system, if the input is x3 of t, then the output is y3 of t is equal to integration of tau is equal to minus 72 2t x3 of tau d tau. Suppose if the new input is a summation of the 2 previous inputs, then I will see what is the output that I am going to get. So if x3 of t is equal to x1 of t plus x2 of t, then what is x3 of tau? x3 of tau is nothing but x1 of tau plus x2 of tau. Then I will see what is the output that I am going to get. So y3 of t is equal to integration of tau is equal to minus 2t x3 of tau d tau. And x3 of tau, we know these values, x1 of tau plus x2 of tau, which is substitute. So integration of tau is equal to minus 2t x1 of tau plus x2 of tau into d tau. So if you do the integration, take it inside, then what you are going to get y3 of t is equal to integration of tau is equal to minus 2t x1 of tau d tau plus integration of tau is equal to minus 2t x2 of tau d tau. So this is nothing but y1 of t and this is nothing but y2 of t. So therefore phi3 of t is nothing but phi1 of t plus phi2 of t. So therefore, as the input is summation of the two previous inputs, so output is also summation of the two previous outputs. So by default, we can say the given system is said to be a linear system. Or simply we can say there are no like a square, the cube, for the input it is not there. So definitely it is, you can say it is a linear system because there are no square terms, cube terms or improper terms are not present. So by default we can say the given system is said to be a linear system because as a summation of two previous inputs we are going to get the summation of two previous outputs. So default we can say the given system is said to be a linear system. So we can say the given system is said to be a linear system. So now we are going to check the causality property. So now we are going to basically check the causality property. What's the meaning of causality property? If the present value of the output is independent of the future values of the input, then we can say the given system is said to be a causal system. Let us see whether it is how we are going to get. So y of t is equal to integration of tau is equal to minus to 2t x of tau t2. Suppose I will substitute t is equal to 1, then what I am going to get? If t is equal to 1 means y of 1 is equal to integration of tau is equal to minus into t, 2 into 1 is 2 x of tau d2. As you can see, the present value of the output is depending on the future values of the input, which is 2. So at t is equal to 1 means here t is equal to 2, so the present value of the output is depending on the future values of the output. The future values of the input, so the given system is said to be a non-causal system. As the present value of the output depends on the future values of the input, the given system is said to be a non-causal system. So finally I can say that if the present value of the input is independent of the future values of the present value of the output is independent of the future values of the input, then the given system is said to be a causal system. Otherwise it is a non-causal system. If the present value of the output depends on the future values of the input, then the given system is said to be a non-causal system. So in this case, it is depending on the future values of the input, so the given system is said to be a non-causal system. So now we are going to check the stable property. So now we are going to check the stability property. Whether the given system is stable or not, then we are going to check. So what is the input output relation for the given system? Y of t is equal to integration of tau is equal to minus into 2t x of tau t2. As I already told, we are going to apply the Bibo stability means for every bound input, if you are going to get the bound output, then only we can say the given system is said to be stable. So I am going to give some bound input like x of t is equal to u of t. This is a bounded signal that I am going to give, and I will see what is the output that I am going to get here. So y of t is equal to integration of tau is equal to minus into 2t u of tau t2. Then we can see this u of tau is defined only from tau is equal to 0 to it is going to present only from tau is equal to 0. So this limit of integration is now goes from tau is equal to 0 to 2t only it is going to come. So y of t is equal to integration of tau is equal to 0 to 2t. U of tau is nothing but 1 there. So 1 into d2. 1 into integration of 1 of d2 is nothing but tau. Substitute limit 0 to 2t. So upper limit minus lower limit we are going to get y of t is equal to 2t. So finally I can say y of t is nothing but 2t into u of t. I can say this is a basically exponential. You can say this is a ramp signal with the slope of 2. The slope of 2. It's a ramp signal with the slope of 2. So it is an unbounded signal. See, whenever you are going to give a bounded input, so whenever you are going to give a bounded input as the x of t, then the output that we are going to get, like this one. It is a ramp signal, the slope of 2. So this is the output that we are going to get. So this is the unbounded output. So therefore we can say for every bounded input, if we are going to get a bounded output, then only we can say the system is stable. But in this case, as we are going to get the unbounded output, so we can say the given system is said to be a unstable system. As the input x of t is equal to u of t is a bounded signal, while still the output y of t is equal to 2t into u of t is an unbounded signal. So the given system is said to be an unstable system. So now we are going to check whether the given system is time variant or time invariant that we are going to check here. So for the system, the input is x of t, then the output is y of t is equal to integration of tau is equal to minus into. So tau is equal to minus into 2t x of tau d2. Tau is equal to minus into 2t x of tau d2. Integration of tau is equal to minus into 2t x of tau d2. For the same system, if I am going to use the input action of t, then what is the output that I am going to get? One of t, which is integration of tau is equal to minus into 2t action of tau d2. If this new input is the delay of the previous input, then I will see what is the output that I am going to get. If action of t is equal to x of t minus t naught, then I will try to see what is the output that I am going to get. That is y1 of t is equal to integration of tau is equal to minus t to 2t x1 of t is x of t minus t naught. Then what is x1 of tau? Wherever t is there, v plus t by tau. Then we are going to get x of tau minus t naught into v tau. So now, x1 of tau is nothing but x of tau minus t naught, right? Wherever t is there, v plus t by tau. Then we are going to get x1 of tau is equal to x of tau minus t naught. Suppose for LTI system is for a time variant system, I've already told you, if there is a delay in the input, same amount of delay should be also present in the output also. Same amount of delay should be also present in the output also. So y of t expression we know. How is y of t minus t naught? 3 plus t by t minus t naught. Y of t is there. 3 plus t by t minus t naught. That's it. So for LTI system, I've already told you, y of t is equal to integration of tau is equal to minus infinity s of tau d tau. And what is y of t minus t naught? Wherever t is there, a plus t by t minus t naught, and we are going to get integration of tau is equal to minus infinity t of t minus t naught into x of tau d tau. If you compare these two things, if you compare y1 of t and y of t minus t naught, both are not same. The 2t is there, or 2 into t minus t naught is there. So both are different. So therefore we can say the given system is said to be time varying system. As y of t minus t naught is not equal to y1 of t, the given system is said to be time varying system. So finally, what I can say conclusion? The given system. So this is a system here. For this system, the input is x of t, and the output is y of t. So what is y of t? Integration of tau is equal to minus infinity to 2t x of tau d tau. So we can say the given system is said to be a linear system, is a non-causal system, and it is an unstable system, and it is a time varying system. So this is the conclusion. We can say the given system is said to be a linear system, non-causal system, unstable system, and time varying system. Now let's see the options. So what I told you the given system is a linear system, non-causal system, time varying system, and unstable system. So now let's see each and every option. In the option A, they are given a linear S dissatisfied. Time variant, no, it's a time variant. So option A is wrong. So for option C what they are given linear S dissatisfied. Causal, no, it's a non-causal. So definitely this is also wrong. In the option D, they are given non-causal S dissatisfied. Time invariant, it is wrong. The time variant. So now let's go for the option D. S is a linear, S is a linear system. Non-causal, S is a non-causal. Unstable, S is unstable. So this is a correct solution of this question. But if they want to comment on the time variant, this is also time variant also. So we can say the given system is a linear, non-causal, time variant, and unstable. So this is going, option B is going to present there. So option B is the correct solution of this question. So now we are going to solve the other question. See the question here. The question says that consider the function h of j omega is equal to h1 of omega plus j into h2 of omega, where h1 of omega is an odd function and h2 of omega is an even function. The inverse Fourier transform of h of j omega is, listen carefully, consider the function h of j omega is equal to h1 of omega plus j into h2 of omega, where h1 of omega is an odd function and h2 of omega is an even function. The inverse Fourier transform of h of j omega is. So in the question what they are saying that, so h of j omega they are, which is h1 of omega plus j into h2 of omega, and they are saying that h1 of omega is an odd function and h2 of omega is an even function. Then what is the inverse Fourier transform of the h of j omega is a time domain expression, or the type of signal it is. So the four options, it is a purely imaginary function is the correct solution of this question. So let's solve this numerical. So now let us solve this question here. Listen carefully. I am going to give a table. This table you have to keep in mind. So listen carefully. This is a signal and its corresponding Fourier transform. If a signal is a real as well as even, the given signal is a real signal and is a even, then the Fourier transform is also real as well as even. If a given signal is a real signal and the odd nature, then the Fourier transform is also imaginary as well as odd in nature. Suppose if a given signal is a real and is neither an even signal or neither an odd signal, then the Fourier transform is a complex function, and the real part we are going to get even nature and the imaginary part we are going to get odd nature. So if you remember these first three things, then getting the remaining three things is a very piece of cake. So you have to remember the first three things. If you remember the first three things, getting the remaining things is a very piece of cake. So listen carefully. If a given signal is a real signal and even the given signal is a real signal with a given nature, then the Fourier transform that we are going to get is also a real part it is also a real part with a given nature. And if a given signal is a real signal and odd in nature, then the Fourier transform that we are going to get it is imaginary, purely imaginary, and we are going to get an odd nature. Suppose if a given signal is a real signal and is neither even signal or neither odd signal, then the Fourier transform that we are going to get is a complex function with a real part even in nature and the imaginary part odd in nature. So if you remember the first three, getting the remaining three is a very piece of cake. So how to get like this? So listen carefully. So for the first one, replace real by imaginary. Here replace real by imaginary and remaining things are same. Real means imaginary, real means imaginary, the remaining things are same. Even. So this for you part. Similar for the second part, replace real by imaginary and here imaginary by real, then you are going to get imaginary and odd, real and odd, right? Here I replaced real by imaginary and imaginary by real. The remaining things is same. So I am got imaginary and odd, real and odd. Similarly for this one, what I am going to do, replace real by imaginary here. That's it. So replace real by imaginary. Here real by imaginary and imaginary by real. That's it. What you are going to get? Imaginary and neither even or neither odd. Then you are going to get a complex function with the imaginary part even in nature and the real part odd in nature. So just replace real by imaginary and imaginary by real. That's it. Wherever I see real, I replace real by imaginary. Wherever imaginary is there, I replace real, imaginary by real. That's it. Only these two things I did. Replace real by imaginary and imaginary by real. That's it. Then we are going to get the remaining three things. So now, if you see clearly what I am trying to tell you. Suppose h of t is there. For h of t, I have did the Fourier transform. Then what I have got h of j omega, which is a h1 of omega plus j into h2 of omega. So this one you see, this one. If h of t is a purely imaginary function, and is neither an even signal, neither an odd signal, then what is the real part? The real part is odd function and the imaginary part is even function. So you can see, if the given signal, the time domain, if it's an imaginary signal and it is neither an even signal or neither an odd signal, then the Fourier transform is a complex function with the real part is odd in nature and the imaginary part is even in nature. Right? This slash means small. It is not an even signal and not an odd signal. But if you see the real part, suppose if h of t is a real signal and if it is neither an even signal or neither an odd signal, in the complex function, that the real part is even and the imaginary part is odd. So you can see, if h of the Fourier transform is h of j omega, which is h1 of omega plus j into h2 of omega, the given signal is a real signal and it is neither an even signal or neither an odd signal, then h of j omega is a complex function, the real part is even and the imaginary part is odd in function. So this you can see. But in the question what they are asking, this one they are asked, right? So this one they are asked. What they ask? The real part is odd they are given, the imaginary part they are given even. So definitely what is h of t? H of t is a purely imaginary function. It's a purely imaginary function and is neither an even signal and neither an odd signal. So see here, option A, real means definitely it is wrong. Whenever you say real means it is wrong, right? Complex function, no, it cannot be complex. It is only purely imaginary, so this is also wrong. Here, a purely imaginary odd function, definitely it is wrong. I already told yes, it is a purely imaginary, but it is neither an even or neither an odd. So a purely imaginary function. So this is the only thing which is going to get satisfied. So it is a purely imaginary function and it is neither an even signal or neither an odd signal. So this point you have to keep in your mind. So only for this one, we are going to get the Fourier transform, the real part is even and the imaginary part is odd. So even in nature. So finally, if you remember the first three things, then getting the remaining three things is a very simple piece of cake. Replace real by imaginary and imaginary by real, then you are going to get these things. So this is a table always you have to keep in your mind. So if you remember the first thing, if you remember the first three, getting the remaining three is a very piece of cake. Replace real by imaginary and imaginary by real. That's it. Don't do anything to even and odd. Keep it as it is. Then you are going to get this one. So therefore we can say h of t is the imaginary signal It is neither an even function or neither an odd function. In the real part of the Fourier transform is odd nature and the imaginary part is a even nature. Similarly, if h of t is a purely real signal, which is not an even function or neither an odd function, then the h of j omega is a complex function. The real part has even nature and the imaginary part is odd in nature. So this one I've already told you so many number of times. So this is the correct solution of this question. So now we are going to solve the another question. See the question here. The question says that the Laplace transform of the signal given figure is. So we have to find what is the Laplace transform of the signal given in the figure is. So they are given some signal. For the signal, we have to find what is the Laplace transform. So this is the signal they are given. So for the signal, we have to find what is the Laplace transform that we need to figure out. For the four options, option C, A into 1 minus e to the power of minus Cs by S is the correct solution of this question. So let's solve this numerical. So this is a signal x of t. So its value is equal to A for t lies from 0 to C, and its value is equal to 0 for remaining values of the t. So for the signal, we have to find what is the Laplace transform. So x of t, how we can write A into U of t minus A into U of t minus C. So simply here there is a rise, here there is a decay. So as basically it is only delta of as x of t is consisting only of the steps. So we can write in terms of U of t, which is x of t is equal to A into U of t minus A into U of t minus C. As you can see, it is rising means plus A, a decay means minus A. Here it is a U of t and it is U of t minus C. That's it. So x of t is equal to A into U of t minus A into U of t minus C. So now I am going to apply the Laplace transform. See, I have already told you in the some formulas I have already told you. If f of t is the Laplace transform of f of s, then f of t minus a as the Laplace transform with the power of minus a s into f of s. I have already told you that. Sure. Listen carefully. Similarly, for u of t, what is the Laplace transform? For u of t, the Laplace transform is 1 by s. For u of t minus c, what's the Laplace transform? The Laplace transform is here a is equal to c, so with the power of minus cs into f of s is nothing but 1 by s. So therefore, then say for u of t, the Laplace transform is 1 by s. For u of t minus a, the Laplace transform with the power of minus sc into 1 by s. So now I am going to apply the Laplace transform on the both sides, and I am going to get x of s is equal to a into u of t is Laplace transform 1 by s minus a into for u of t minus a, the Laplace transform is e to the power of minus cs by s. So a by a is a common, so I am going to write a, and s also I can take common. So if I take a by s as a common, then what I am going to get? A by s means here 1 minus e to the power of minus cs. I can take s inside, then I am going to get a into 1 minus e to the power of minus cs by s. So this is the transform, which is the Laplace transform for this signal. So you can see, I must remember, for f of t, the Laplace transform is f of s, and f of t minus a is the Laplace transform with the power of minus cs into f of s. So with the help of this formula only, we have solved this question. So this is the correct solution of this question.